Welcome back, friends and amp enthusiasts. I have a very special one here today. This is a 1964 Vibrolux Reverb amp. And if you know, you know. This is one of the holy grails of the Fender line. This is a very sought after amp for many amp enthusiasts for a variety of reasons. One is its rarity now, and two, because it is definitely one of those ones that a lot of players have looked for because of its tone and characteristics. So we're going to get into the restoration of this, full-on restoration, not just a repair video. This is going to be a restoration video. This was recently acquired by a friend of mine who wants to keep this as original as possible. I did look at this circuit already, and someone has made one modification. They added a master volume to the back of it, so we'll take a look at that, but we're going to get rid of that. We don't need a master volume added here, and it's actually pretty interesting. If you guys have ever added, anybody here has ever added or had a master volume added to your amp, just at a quick glance, I haven't really looked exactly at what this thing is doing, but I've never seen one done quite like this before. Now, here's the condition of the amp. I've already turned it on. Well, I inspected it first. Inspected everything. There's no capacitors that have blown up completely. The amp is very noisy, but it works. And I brought it up with Variac very safely and inspected everything and tested everything. But we definitely need to go in, and it needs a full cap job. The caps that are in this are not the originals, but they are very old. So we need a cap job. We need a basic servicing, clean all the pots. There's some really dirty pots, really scratchy, especially this treble pot. When you turn this thing, it's just like, it's all over the place. The original foot switch came with it. But the thing is I think this cable is kind of at the end of its time here. It's just very crackly, very noisy. As soon as you attach it to the amp, it's like 1,000 times noise. Matter of fact, I was picking up all kinds of radio signals and stuff with that connected. However, I don't think my friend is going to need this, and he has another foot switch that's newer, that's the same thing for Fender Princeton with the vibrato and reverb, so we might not even need to do much with this. I'll try to probably clean the contacts and also retest everything after we're done the work to see if it's quieter. But we have a 2-prong cord, and what's interesting is that the work that was done on this amp to add the master volume, and at the same time it looks like that same tech replaced the caps, that looks like it was done a long time ago. Because why wouldn't they have replaced the 3-prong with a 3-prong cord to make this thing safe, right? We do that nowadays. It's almost common practice across the board. You never leave. I mean, the shock hazard is extremely high with a 2-prong cord where the amp isn't grounded. And the other thing is it should hopefully make the amp a lot quieter if we have a common ground point, you know, where this gets grounded to your house and makes it safer. It also should be a little less noisy in general, because those noises can get shunted to a real grounded house, basically, when it's plugged in, right? So long story, we've got a lot of work to do, but this is going to be so much fun. We're going to keep it original. I've already ordered parts for this, so I'm ready to start working. There's caps and things we're going to change. We're going to kind of do the whole sort of servicing, get it up to speed, but we're also going to clean the grill cloth and try to keep that original. We're not going to be able to get it looking brand new because there are a few holes and it's really faded. That's probably old cigarette smoke from the 60s and 70s, and God knows what else it's been exposed to. But we should be able to brighten it up a bit, and I have some techniques that'll work really well for this. Maybe not perfect, but I think it'll look a lot better. Smell a lot better too. And the Tolex will be completely scrubbed clean. I'm going to try to clean all the knobs, all the chassis straps, everything. Polish the metal wherever I can. And there's a lot of paint and stuff on like the side, for example. There's some white paint, and I think there's some red paint on the back. Let's go ahead and take a look at the back, and I'll show you what's in this thing. Here we are looking at the back of the amp, and I'm going to go ahead and remove this panel so we can see the tubes a little better. I've already taken all these panels off, and I just tacked a screw on each side just to kind of keep it in place for now so we can see what it looks like. Of course, like I said, I've already taken this all apart and inspected it, but I wanted you to be able to see this, at least what I'm seeing before the restoration happens. So first thing that probably pops out at some of you who know what this amp is, the speakers are not original. So I think the speaker change was probably done at the same time this guy got the master volume done, which is over here. I'm gonna go ahead and unplug the reverb tank for now, just to get these wires out. And also I took the tube covers off here. So all the glass that's in this is probably original. If it's not 100% original, it was changed early on, because these are all very old tubes. This is an RCA and this is a Sylvania for the power tubes, the 6L6s, and then this is a 5AR4 rectifier, which is I forget what this is. Yeah, GE. So all these tubes are mostly like the old school American brand, GE, RCA. This is a GE. A lot of 7025s and 12AX7s. This one's a 12AT7, which I think is for the reverb driver. But yeah, so quite a good tube array here. I haven't tested the tubes, but you know, I don't know. There could be some microphonics going on. We'll check all that. We'll test all the tubes as part of this. But yeah, the speakers have been replaced, and I think my friend that bought this looked these up. In the next section, or one of the next sections, I'll tell you what they are exactly. But supposedly they're supposedly pretty decent. However, I did notice that one of them I was having problems with initially. I was having problems because this little spot back here where the connection from the positive on this speaker goes into the speaker here, and then there's a little wire that goes down into the cone of the speaker. That wire needed some solder on there. It was starting to crack. That's working fine now. Both speakers are working fine. However, there's a rattle going on with this one. Now, I've been in amps before where I heard a speaker rattle. I don't see any holes on the back, but that doesn't mean there's not a hole somewhere on this thing. And the other thing is, there could be just a little piece of wood or whatever that's on the other side of this cone that's just bouncing around in there. I've had that happen before. Matter of fact, one of the last repairs I did, somebody brought me a combo amp with a single speaker and said, it's got this horrible rattle. And the first thing I did was take the speaker off, and there was a screw in there this big. The amp was fine. You know, it was like a modern Fender amp. I don't know how that happened, how it got in there, but there was a screw sitting down in the bottom. So we'll take a look at all that. I don't know if we're going to wind up keeping these speakers, but after we service it, we'll test it with these speakers and see what it sounds like. My buddy's got some other speakers that are 10-inch. These are 10-inch speakers that he really prefers to use in these kinds of amps that have the 10-inch speakers, so he may wind up swapping those himself. However, I am going to replace this speaker cordage because it is quite old and quite frail. I just noticed that in certain spots it's just, you know, if I move it, the speaker can go in and out. So I just think that just needs to be redone. So yeah, so that's the tube array. What else? The speakers. The tank is original, and the tank sounds fantastic, although it is quite noisy. And I think a lot of that has to do with when you have the switch hooked up. If you take the switch off, it's not too bad. So yeah, we're gonna remove this master volume and we'll take a look at it first, show you what they did and how they installed it. It looks different to me than anything I've seen. It almost looks like one of the Lamar Trainwreck style, but it's different than that. It's a different type of master volume. I can't really, I don't know. It looks like it was done a long time ago, and it's a very strange pot. I got to show you this thing because it clicks. It's like a click setting pot, but it's not a switch. It's not like switching 1, 2, 3, 4, 5, 6, 7. It's almost like there's 20 or 30 clicks to go all the way around, maybe 40 even. I don't know. It's weird. There's a little wheel on it and everything. So yeah, interesting stuff that you find in amps. And I have another story coming up later about an interesting find in this amp that I found hiding underneath of the reverb tank. And we'll get to that in a little bit. So I'll go ahead and open it up and we can take a look at what's inside. Okay, editing Mike here. This is, I'm putting this in early in the video just as a kind of a laugh. But I wanted to do a little segment on the craziest crap that you find inside of old amplifiers and old vintage gear and stuff. I've found some really nasty stuff before. I've found lots of mouse turds and mouse skeletons and all kinds of different things, right? But this one kind of shook me. I've never found anything quite like this ever inside of an amp. And I don't know if it'll be the first time or not, but we'll see. So before I got into restoring this amp, this is it restored. You're about to watch the restoration video. But I opened this up when I first got it to look at everything. And underneath of the reverb tank was hiding this little pouch, this little thing. And I thought, oh, that's cool. Maybe somebody put some spare fuses in there. I do that with all my amps. I have a little pouch or a little baggie of spare fuses, and it just looked like this with these papers in it. All these little sort of like separator papers. And I thought, what is this thing? And I couldn't get it out. It was all stuffed in there with papers, and I finally started getting things out, and I noticed there's actually something on some of this paper. What is this? And I was actually making a film for the customer at the time, showing him something about the speakers in the back. And I was like, what the heck is this thing? So I can't show everything because of the explicit nature of this, but here's what we found. And there's more than this. This is just a part of it. This is the part I'm going to show. So apparently somebody who owned this amp, probably in the 60s or 70s, this was their little hiding spot for some of their little risque images here. These ones look like newspaper. They're very, very old and frail. I had to cover up some of the parts, and there were others like this, a few others, but I think these were actually old magazine. These came from an old magazine where they used like a newspaper type of material, but they're very old, very frail, no color, sort of a sepia sort of color now, but maybe they were black and white, I don't know. But yeah, there's definitely some risque stuff going on. And then I found these actual photographs of somebody that maybe the dude knew. Maybe the owner of this amp had a crush on some of these fine young ladies. I have no idea, but if anybody knows who these women might be, leave a comment. The only ones you can really see the face are this. I think this is the same person, same outfit. Yeah, and then I don't know who this one. If you can see the fingerprints on the it's actual photograph paper. So there's definitely, I don't know if maybe this guy developed these himself, or the person. When I say this guy, I mean the person that included this little stash of photographs. Maybe these are groupies, I don't know, but they definitely look like three separate women. And of course some other very risque photographs that were newspaper clipping things, and I think there was a few others in there that were very similar. I don't need to include them, but yes, interesting find in an amp in this little pouch stuffed underneath of the reverb tank. So ladies, if your husband has an amplifier and you want to find where his stash is, check under the reverb tank, all right? Nowadays we got the internet, so it's a whole different ball game, but I also found this pick. What does this say? D. Andrea? So I've never heard of that, if it was a brand of guitar string or picks or something, but this is like wafer thin. Very, very thin. But yeah, D. Andrea. So if anybody knows about that, where that may have come from, was this something popular in the 60s or 70s, or I've never seen a pick like that. But yes, interesting finds, things that we find in old amps. I'm sure if anybody has any cool stories and you want to tell me, if it's not too, if it's internet appropriate, I guess, you can put it in the comments. If it's not, then shoot me a private message. But I love to see what people find in these old things. I know Shy from Resurrection Repair has had a ton of crazy crap that she finds inside of her pianos and keyboards and things that she repairs, like facial hair from a guy that was shaving for years over top of his piano. That's disgusting. That one almost made me puke. Cat vomit, all kinds of crazy stuff. But this was very interesting. I was not expecting to see a little stash of photographs of, hopefully, ladies that are safe today. But anyway, just wanted to put this out there. All right, here's the underside of the chassis. You can see that these are not original caps. These are ambassador caps made in Japan. And another interesting thing about this is that they're 30 microfarad. All of them are 30 microfarad, which, if you look at the schematic for this Vibrolux Reverb, which I also believe is a AA964, even though on the inside of the cabinet it says AA864. I don't believe that Fender actually ever produced an AA864, because I cannot find a schematic or a layout diagram for any 864 in a Vibrolux Reverb. Now, they did have, I think, some other models, I don't know which ones, that had an 864, but if you guys, if anybody out there watching this knows of an actual diagram, whether it's layout or schematic, that says Vibrolux Reverb amp, not just Vibrolux, but Vibrolux Reverb AA864, please let me know, because I've done a ton of research and I cannot find it. Now, I know Fender was notorious for mistakes with the diagrams, the tube layout diagrams and all that, and the model numbers that were in their amps. Sometimes they posted the wrong ones inside. The one that's inside of this amp says AA864. But looking at the circuit, I believe this is a 964. I could be wrong, because there's a few others. Let me just show you. I printed these out just so it'd be easier to flip through. They made an AB568, but I don't think that's correct, because I look at the way they did the bias here, and that's not how the bias is being done. Or at least it doesn't look like that. And there was an AA270, which I don't think this is it, because there was something I looked on this. I'll verify that for sure, that this is a 964, but I believe so far, just at me glancing this seems to be the closest to what it is. Now, again, this has been modded with a master volume, and they did some weird stuff around the bias circuitry for that master volume, so I'm going to show you what that is in a minute. So maybe it was something else. I don't know for sure, but we're going with that for now. And these caps are double their rating for this amp. So we need to put some 16 UFs in there. Again, I know Fender wasn't using Japanese ambassador caps. I read that these caps are not great. Now, none of them have exploded, but I don't think you can even buy those now. So we're going to wind up putting these F&T 16 UFs in there, because that's what it calls for. All these caps are 16. There's 2 of them that are in parallel, so that'll be 32, right? But then the rest of these are 16. So we're just going to put 5 16s in and keep it as original as possible. Probably going to replace these resistors, because they do look a little dark. And these are dropping. This dropping resistor here looks a little crusty. I haven't even tested those yet to see if they've drifted, but we will. Again, we'll clean all the tube sockets and everything, but let's flip this guy over and take a look at the underside. All right, isn't that a gorgeous sight, my friends? So everything on the board from here all the way up to there pretty much is original. It doesn't look like anything's been touched. These electrolytics here need to be changed due to their age. The bias one down here needs to be changed. But it doesn't look like anybody's messed with the blue molded caps or the disc caps or anything. So, although this one might have been changed here. This green one, I'm not sure, but that looks out of place. But yeah, see what they did here? This master volume, they added it over here. Hold on, I'll probably have to give you a better view of the actual, let me see if I can tilt this upward. See that little wheel on there? That's just the weirdest thing. I've never seen a pot like this before. But it's a dual gang pot, so it looks a lot like the Trainwreck Lamar style. But this wheel thing is weird. So anyway, it looks like it's got two pots. It's dual gang. They're running these shielded wires, and that's good. Shielded wires. Oh, and by the way, this does seem to work. It does turn the volume up and down. But I'm curious with all these mods, had, you know, the 30 microfarad caps, this thing, and here's the thing that I think might potentially be changing the sound from its original sound, are these two caps right here that were added. So you see they put a terminal strip right there. Here, let me get down closer so you can see this. Okay, so this little terminal strip with the green wires here, these are coming from the master volume pot, right? So it's dual gang, meaning it's two pots. So there's one pot going here and there's one pot going here. And as you turn the knob, it's, you know, adjusting the variable resistance of both pots at the same time, right? So it looks like there's this cap and this cap in that circuit as well, where these red wires are. This is the shield, the silver is the shield, and then there's a yellow for, let me see what side of the pot that's hooked up to. It looks like the middle. Yellow's on the middle lug and the red's on the outer lug. But they have these these are 224Ks. So these are 0.22 at 250. And it looks like they're going here to the bias resistors, the 220K resistors. So yeah, I would think that this would affect the tone potentially. Because in that other type of master volume that I've seen done sort of like this, these caps weren't involved there. And the other thing to notice too is that over here with the bias, all this stuff has been kind of changed as well. So there's a 220 UF cap here. There's a little, I don't know, it looks like a diode. I can't see without glasses on. There's a diode over here, and then there's this big resistor here, and that all looks like it's going through this bias circuitry. So I don't know what they're trying to do here exactly, but I don't know, is he trying to, it doesn't look like he's trying to bypass. Where's this go? Well, I'll have to look at this a little closer. I'm going to do that off camera and see if I can figure out what he did. But either way, we're going to rip that out. We're going to put this back to original. That's the way my friend wants it. He wants it as original as possible, but we want to make it safe. We want to update any of the electrolytic capacitors that are far beyond their life. So that'll be all these brown guys. And then we're probably going to replace a few resistors for safety that are just, you know, bias related things that we want to make sure that they're solid. We've got good negative voltage going to the tubes to idle them. Anyway, long story, everything else looks original besides this stuff that was done here and this stuff for the master volume. So yeah, also, I think, is that like a 27K resistor? I'll have to take a look at that. If it is, that would be the 964 model. Sorry, I'm thinking out loud here because it looks like, yeah, 27K with a 10K linear pot. Negative voltage is negative 42. on this model, and it looks like they used on this one, the AB568, they used a 15K resistor with a 10K pot, and then they have these two 10Ks going to 100K. Yeah, something's... I think this is definitely closer to this. But again, this guy added all this stuff here, so... but yeah, so anyway, we're gonna start planning out the work here. I do have these really nice. I hope they fit. They do look a little bigger than I expected them to look, but F&T makes... I've never used these in an amp before, but they're super cool. They're just like these old ones. It's like a recreation of these old Astron caps, where they had two 25 UFs at 25 volts in one can, right? And they used 3 of those. So I've got these, which are the F&T. I love F&T brand. Really good, high quality stuff, where it's the 225 UFs caps. So it has the 2 terminals. It's just like this, but it is quite big. I think we'll be able to make it work. It's just a little bigger than I thought it was going to be. It's bigger than these. But that's essentially what that value is. Heavy duty. Heavy duty. This should last a long time and be very high quality. So yeah, as long as we can make them fit. Otherwise, what most people do nowadays for these is just put 2 separate 25 UF caps in there, something like much smaller size. And then I've got this 100 UF at 100 volt F&T that I was going to replace this bias cap with. That's just, I know it's a little more microfarads than what was in there currently, which was a 50, I think. No, 25. But for the bias supply, that's usually what modern day value is used, and this is high quality too. So yeah, so anyway, we've got the parts to do all this, and I've got a single one for this guy, a Sprague here that's 25. So yeah, I haven't decided. I mean, I had planned on using these. It's just as long as they look like they'll fit okay, I think they'll be fine. I mean, they're about the right length, almost exactly the right length, but then there's a little bit of wire here that will it fit underneath. So we'll make it work. You know, my friend wants the highest quality stuff in here, so we're gonna do this right. So yeah, I just wanted to show you what everything looked like underneath here. Mostly original, a little bit of stuff done to it. We're gonna put it back. We're gonna get the bias set up straight like it's supposed to be. Replace a couple old components there, rip out this other stuff, and then rip out this master volume and put all this circuitry back to the way it was. Yeah, so very cool. Oh, and also replace the 3-prong grounded cord. I may wind up starting with that. And take the DeathCap out because that's sitting under this switch. So I'm going to show all of that for this video so you can see how we do everything step by step. And there's a lot of cleaning work that needs to be done, and it's super important for this amp because all these scratchy pots, and we need to see if they're even cleanable just with spraying them out. We might need to unsolder and take some of these apart if they're really bad and try to clean them to keep them original. The worst case scenario, we would have to replace one. But if we have to replace one, I've got some pretty common Fender pots that have that same 2 to 35 sweep. I don't know if you guys know about that, but like Fender, let's see if I have, here's a 250K audio treble pot. So this is a Fender, this is a special kind of a pot. It's 250K, but it also has that same sweep that Fender used on these old pots, which, you know, I built amps for the customer that I'm doing this for, and he is a musician that he feels that sweep, like he needs to feel that same feel of a real Princeton or a real Vibrolux, whatever the amp is. It is a different feel when you turn it from 0 to 10. You know, you got a certain range that you're used to, and that range will be different if you use a standard pot versus one of the Fender ones. So again, I want to do that. I want to keep it as original as possible. Hopefully we don't have to replace any of these and we can just clean them. We got to clean all the jacks. We got to clean all the tube sockets, inspect everything, inspect all the wiring, inspect, I mean, all this looks pretty good, but I'm going to clean all this out in here. So yeah, in this video, we're going to be doing a lot of cleaning work, but it really needs it. It's definitely got some age to it. I can see some gunk and funk on some of these connections. It's really sticky feeling and greasy, like really sticky and gummy over here on these guys. So these just need to be cleaned and polished really well. I'm sure that all the tube sockets can use a really good thorough cleaning. All of them look like they're in great shape though. I don't see anything that's cracked or been abused, or you know, nothing's loose or shaking around in there. Everything feels really good and solid in this amp, which I'm super happy about. A couple of resistors here are looking a little dark, so again, on the power tubes I may replace these guys, but that's just all standard kind of stuff that I do to keep kind of make the amp safe and also more reliable. There's a little roach clip here for the tremolo effect, and these caps right here setting some of those settings. The tremolo was working at one point, and then I forget what I was doing. I was testing some things and then it wasn't working. So I'm not sure if one of these caps are going bad or even this roach clip needs to be replaced for that. But yeah, we're going to look at all that stuff. But I think I'm going to do the cleaning, servicing, and replace the power cord, and I'll do all the caps and like the stuff that I know first, putting it back to original, do all of that first. Then we'll bring it up slowly on a variac. We'll test everything. And then we'll kind of poke around and see, is there any sensitive components and things like that, because I know the amp's working. I don't have to troubleshoot it to get it to work and know that there's a dead component somewhere, because all components seem to be, knock on wood, functioning at the moment. But again, it just really needs the service because it's very noisy and it's time, right? It looks like somebody, I don't know if Fender did this, but this solder joint here I can see is a little sus on the chassis. It looks like a very small solder glob, and there's a lot of flux around it, so it's hard to tell. It almost doesn't look like it's a really good bond. But yeah, things like that, I'm going to check all that stuff and make sure nothing's loose and can't just pop loose. This solder connection here, this one. This has the brass plate here, so there are some solder connections soldered directly to the brass plate. I'm going to clean up all that old flux and really inspect these good and push on them and make sure they don't just snap loose, because I've had that happen before. Yeah, there's like 4 of them right here. You can see this one, this guy under here. We'll get close-ups of this stuff so you can see it later, but yeah, they seem to be fairly solid and on there, but all right, so we got our work cut out for us. Let's get to it. right, we are back, and if you watched the time-lapse video that I just did of the cleaning, basically I just wanted to start with a clean surface, you know, a somewhat clean surface. We'll be doing a lot more cleaning here as part of this restoration, but essentially what I did, if you skipped ahead, was I vacuumed the entire chassis out, just try to get as much dust and debris and stuff, little flakes of things here and there, but get all that stuff clean so I have a nice surface to work with. Cleaned the face plate, took all the knobs off the back plate, cleaned all the jacks with alcohol, the switches. What else did we do? The RCA jacks, got those really nice and clean. I just figured while I was cleaning I would get some of this stuff done. We still have more of that to do, but at least now I can start working on the circuitry and I have, you know, kind of a clean surface to work with. So I just wanted to get some of that out of the way. Alright, so I'm getting my iron ready here because I want to start on this power cord and also making the amp safe. So okay, here we go. So what I'm going to do, I have a new power cord ready. Just want to make sure this is in focus for you guys. Sorry if this goes in and out of focus. I'm trying to get it as close as I can, but also kind of give you the overall view to show you where I'm working inside of the amplifier. This whole section here where the power cord comes in, there's this accessory outlet. There's the ground switch, which we will not need anymore. The DeathCap we won't need anymore. We will need the fuse, and I am going to replace this fuse holder because it didn't have a cap on it. The spring is gone, and there's no way to hold the fuse safely in place there really anymore. So I have a completely new assembly for that, which is the same kind of style. So we're going to do that. We're going to replace that. Then there's the power switch and the standby switch. So really everything up to the power switch we're going to be rewiring and making safer. And it's actually going to be a lot simpler now because we don't have to worry about this ground switch, the polarity, because now we're going to have a full grounded amp. So first thing I want to do is remove, and sorry if I bump the cameras here a little bit because it's a little difficult to get in here, but I've got this solder remover gun here that I'm using just so that I can make nice clean connections, get rid of some of that old solder. I was just going to snip a lot of these wires out, but I'm going to have to put the... See how clean that makes that? Really nice to remove some of the old solder. But yeah, this is just a desoldering gun that has a pump in it that automatically, if you've seen some of my other videos, I use this a lot. I actually use this a lot for soldering because I really like the temperature control of this iron, and I feel like, I know it's a little bulky to use, but it heats up really well and does a good job. And especially if I'm resoldering something, like replacing a part, I can get rid of some of the old solder first and just use the same gun to do the soldering job too. So it just depends on what I'm doing. Alright, this one, I feel like sometimes if you can't get it to melt, you might need to add a little bit of new solder to it. Give me a second. We have a little stubborn one on that side, so I'm just going to take some new fresh solder here, and the noise you hear is this pump, and just add a little to it to get it to heat up and flow and melt. There we go. So it's just more about heat distribution than anything. Okay, we have this wire and that one. And is there... Oh, it looks like that lug's bent. So this accessory thing, I mean, not a lot of people really use these. And here's the other thing about this. So this port you know, this plug, it's only a 2 plug. It doesn't have a ground on this little accessory port plug. Oh, is that even? Sorry, I'm trying to see if that's broken. It almost looks like it's broken. Alright, I'm just going to leave it like that. I'm going to go ahead and wire it up, but it doesn't have a ground. So anything that you plug into this, like let's just say you're going to use like a pedal that you always have plugged into this one plug. It's just convenience, right, to use that. The only problem is without a ground, you know, whatever you plug into it is not going to be grounded, like to earth ground. So I'm going to go ahead for originality and leave it there and wire it up, you know, with the new power cord and everything. But I don't know. It's just one of those things where it'd be better if we replace it with something that would fit in the same spot that would actually have a ground. You know, would have a hot, a neutral, and a ground. But anyway, long story. We're going to hook it up. Let's get this switch out of here. Matter of fact, for this one, I'm going to go ahead and just... Hold on a second. This is pushback wire, so that's cool. I was going to just snip these out of here, but I'm going to leave this switch in there, even though nothing's going to be connected to it. It's always something where if you did want to add like a mod or a feature to the amp and you needed to make it switchable, you could use this switch because it's not going to be needed anymore. So I'll go ahead and just make these, I'll get rid of all these things and make it clean again and just keep it original. These are really nice switches, by the way. I've used these in new amp designs for different things. They're very heavy duty. Now this is the DeathCap. You can see they kind of just shoved it under here, and it's soldered to the chassis. What's cool about this is the same blue molded caps that are in the tone section of the amp. So this could be reused for something, especially if there's a bad molded cap. The value is pretty common. I think it's 0.047, which is the same as I think the first cap down here. So this cap can be used, which is awesome. It's, you know, it was in the position of a DeathCap, but it's still the same type of capacitor. So we'll save that. Just trying to make this clean. Get rid of this guy. Here, actually, let me get this out of the way. Since this fuse holder thing is kind of not working anymore, I'm not worried about cleaning that up too much. Alright, just get rid of these wires. Kind of vacuum up some of that old solder. And yeah, that switch is great. I mean, that could be reused. But I'm going to keep it there for originality. And we're going to keep this accessory there. Alright, so we just need to unhook. I'm going to go ahead and we're going to put a new piece of wire on this power switch, I think. So I'll go ahead and remove this wire. And I'll leave this black wire is for the to the transformer for one side of the primary of the power transformer. So there's two black leads, this one here and this one that goes to the power switch. So let's go ahead and get rid of this because we're going to be replacing that. And let me just I might need to snip out the DeathCap, but I'm going to see if I can actually unsolder it. Give me a second here. I might have to flip this over. Okay. Yeah, see, it's that little solder glob there. That's where the DeathCap is. We don't need that anymore. Now it takes a lot of heat to unsolder something off the chassis. I may need to turn up my iron a bit. I'm going to see if I can get some of this old solder up. Add a little bit of new, get it to flow. I'm using the side of the iron here to really try to heat this up. Oh shit. Sorry. It's not imperative that this needs to be completely. I could have snipped it, but I'm trying to preserve as much of this lead as I can in case we do reuse this cap. Okay, I think my soldering iron thing is stopped up. Yeah, I gotta empty it. So what happens is if you start removing a lot of solder, the little canister here gets full. Or there's something that will block it. So I just have to empty that out. And probably yeah, there's definitely a couple chunks of solder in there. Just clear this out and just keep going. Okay, let's see if I can remove just a little more of this. Okay, I got rid of most of it. At least the main large glob is gone. And now, take that off. Okay, I'm going to try to flip the amp back over again. Give me a second. Okay. All right. Okay, readjust camera angle for you. Okay, yeah, so all that stuff's been removed. Now we got to remove the power cord. And I highly recommend, if you're getting into amp repair and you're doing a lot of this work, one thing that could save you a lot of aggravation with power cords like this. I mean, I personally, when I design amps, I prefer to use the IEC jacks for my amps. Just the IEC receptacle, something like this. Like this is one that has, you know, the ground and the hot and the neutral, but it also has a built-in fuse. But you can get them without the built-in fuse. But I prefer to use these if I'm designing a new amp, because that way the power cord can be completely detached. You could buy a longer power cord, you could buy a shorter one, you could replace it easily without having to unsolder anything, and you can completely remove it and pack it in your bag and go. That way you never have to mess with any of this stuff replacing a power cord. You just buy a new one and you plug a new one in, right? But these old amps, they didn't have that, right? So we need to replace it, and we're going to try to make it the same. So we're not going to go ahead and drill out a big square and pop one of those IECs in this, because we're trying to keep this as original as possible. But one thing that will make your life a lot easier is one of these. This is called a restrain tool, or a restrain relief wrench. and it's designed to remove and install these little strain reliefs that go around the power cords. You can find these on most of the amp supplier type sites. You know, they're probably like under $10. I don't know what the actual price is. I got this probably a decade ago. But see how it's just specifically designed to clamp around there. And I'm telling you, I could spend sometimes 10 minutes with a regular wrench, and it's not as effective as, you know, a minute or two with this thing. But first, I gotta move the camera so you can see. Give me a sec. I just wanted to change the angle for you, but see, if I clamp on this like this, pops right out. It's just the perfect amount of pressure and everything. It's just so easy to remove these, but it can be such a pain in the butt without one. So again, you can do it without one, but sometimes you just be wrestling with it for days. This one, this strain relief appears to be in really good shape. I don't see any cracks or anything, so I may wind up reusing that. I do have replacements, but let's get rid of this old 2-prong cord. I'm going to remove the screw and this little bracket holder here. Whoop. That goes on the inside of the cabinet, and we'll save that here for later. But now we can totally get rid of this power cord. This is not needed. Completely trash now. Don't be plugging this in. So here's our new power cord. This is a good quality 3-prong. There's our ground. That's what we were missing, right? We didn't have a ground. That's what this big part is right here. And the other's a hot and a neutral. So what we want to do is, I asked my friend what size power cord would be good, because standard sizes, I mean, you can get these in all sizes, really. But standard is probably like 6 foot, 8 foot, 10 foot. He wanted to go with the 10 foot. Longer's a little better, because you never know when you need that extra foot or two to reach somewhere. And then you don't have to worry about getting an extension cord or a power strip to extend it a few feet. So he wanted to go with the 10 foot. We're going with the 10 foot. So that's what this guy is. So this should be about the same diameter. Where did I get this from? Amazon. They sell tons of different power cord, you know, things, and I just look for a high quality, high rated one. That's all we need. Now what we do need to do though is strip this guy a little bit. So I'm just going to set this here for a second. I'm going to knock something over, I know it, while I'm reaching for a different tool. Let's see. Oh shoot. Alright, at least I didn't knock the camera over this time. Alright, so I've got my strippers here. So here's what I'm going to do. I need to figure out where are these going to land to figure out how long they need to be. They don't have to. I just want it to be clean, so I don't want to leave too much slack, but also not too little where it might be pulling on things, right? We can get rid of this death cap now. Here it is. Nice little blue molded cap. We'll save this in case we need it for this amp or for some other amp. 0.047. Yep. That's the old Fender blue molded. We'll keep him. Can totally be used for tone if we need it. Alright, so when this guy goes in, I'm going to need to make a ground connection, a dedicated ground connection to the chassis here. So I'll probably need an extra inch or two for that, just to make sure I've got enough room and I can strip it and have extra. The hot wire, we don't need it. We do need it to go to this plug here. And the well, I guess we can do the hot and the neutral to this plug and then just do the extension wires over. Typically what should happen is it should go through the fuse first. This doesn't really matter. It doesn't matter that it goes to this first, this accessory plug, because it's just like having a plug outside of the amp anyway. It really has nothing to do with the amp itself. So even if a fuse blows, what we could do is we could run it through the fuse, and that way if the fuse blows, then it cuts power to this. maybe we should do that too, because what if somebody's being stupid later on down the line? I'm not saying my friend who's going to own this, but if he sells it later and somebody else plugs something else into this, and the combination of the two plugged into the same socket is causing a problem, maybe it would be safer to have this cut off as well if a fuse blows. So we'll run it straight to the fuse first, and that's going to be the hot, which is the black. All right, so I need to have enough wire here that the black goes all the way over to the fuse holder first, and then I'll run a wire over to this here. The other thing is the switch, so that's even further. So what I'm going to plan on doing here, I can always cut it shorter, but I'm going to do about this much because the switch is all the way over here. I'm going to make sure I have enough so that the strain relief would be somewhere around here. And then what I can do is I can probably strip it. There's not a lot of room here, so maybe I'll strip it right about here. Alright, so what I'm going to do is I'm just going to score it a little bit with an X-Acto, and I'm just pressing it in. I'm trying not to go deep, just enough to score the outside, and then you see I'm literally pressing very lightly and just bending. There we go. That way I'm not cutting through the other wires. Now you'll see a lot of powder here. They put like baby powder in there to make this easy to come off. Some kind of talc or something. So I'm just gonna, you see it kind of got all over my desk here. But yeah, it does make things a little bit smoother. It would be really hard to get that rubber off if not. So I got plenty of excess wire here. I can always cut these down a little bit if needed. And we need to have the white wire go at least to like there. So that's where our strain relief can go in, somewhere around here, and we've got plenty of extra to work with. Okay, so I'm just making sure I have enough. I would say right about here. So let's take it, all right, let's take it, and this is new, so it's going to take a little bit of pressure to close this, but I'm going to use this tool, and it should fit right on here, top and bottom, really nice, and just sort of work it around a little bit. It's got to really smush down on this thing, and kind of wiggle it and push it. There we go. See how easy that was? So easy with this tool, I'm telling you. I've wrestled and wrestled and wrestled with these things with a wrench, and it's just so difficult. Alright, so what's good about this is I'm applying quite a bit of pressure, and it's not coming out. And I apply pressure this way, and it's not coming out. But what I like to do is also put a zip tie around the inner side of it as well, just so that it can't slip for any reason at all. It's just a little extra safety, and I'll show you where I put it once I swap the angle. Sorry about my head being in the way there. Maybe I should just put this on when I have this amp turned around the other direction. I'm about to turn it around anyway soon because it'll be easier to solder and show you what I'm doing. But all right, I'm just going to make that as tight as I can. And it's just an extra little security on that side of it. But it shouldn't go anywhere. It's the right size. It doesn't spin around. And I can really yank on it pretty good and it doesn't come out. So, alright. I'll move this light. Alright, let me stop a minute. I'll change angles. Alright, you might be asking yourself, or possibly have asked yourself while you watch this, Mike, if you do a lot of this amp work, especially building amps and these kinds of repairs, why don't you have a chassis stand? Well, I actually do. I built one a number of years ago, which was about $150 to buy the same exact thing, and I kind of did the same exact layout and built it myself out of pine wood that I had left over. routed it and everything. I didn't paint it or anything like that, but it works. Thing is it takes up a lot of space on my bench, just having all that extra wood and stuff. And it is nice, but I'm flipping this thing around constantly, and I would have to be readjusting that thing. It's just a little easier for me to set this up on these boxes just for now. Sometimes I feel like if I'm going to be working on an amp, like let's say I was doing a lot of soldering and adding components to a board or something like that, yeah, it might come in handy because I'm leaving the amp in one place. But here I'm flipping it around and changing the angle and it's just kind of, it's a lot with a chassis stand. So that's why I'm deciding not to use it at the moment. It's just, and it gives me a little more room, especially when I'm filming this stuff. But I do use it occasionally. It does come in handy. So, I mean, you can buy them yourself, but they're pretty easy to make. I mean, I just looked at a picture of one and I was like, oh, that looks pretty straightforward. And I just figured out how to build it. So, all right. So what I'm going to do here is black is hot, right? Black is always the hot, usually on all these modern cables, especially if you have black, white, and green. Black is always going to be the hot. So what I'd like to do is always take the hot to the fuse first for safety reasons, and I'll show you that in a second. I just need a wrench. I do need to get rid of this old fuse holder. Let's see if we get this guy out of here. Yeah, this, like I said, this fuse, I wish we could keep the original fuse holder, but there's something wrong with this one, and it's missing its cap. And the cap that I temporarily had put on there sort of fits, but there's no spring. It needs to have a spring in there to hold the tension on the fuse. So yeah, unfortunately, when my friend bought this, it didn't have that spring or the cap, and I tried, actually did put a spring in there. Oh, it fell out. Temporarily I put this little spring in there to hold the fuse, and it worked while I was doing my demos. But I don't want to jerry rig this thing. I just want to put a brand new one in, and I've already got the fuse in there right now. So it's the same type of fuse holder. As a matter of fact, I think the cap even looks the same as the original. It has the same kind of lettering. So the only problem I think is that this might be a little bigger. Oh, I forgot about that. Yeah, they made these just a little... Wait a minute, maybe not. Hold on. Shoot. Yeah, see, here's the problem. The hole is cut and it's flat on two sides, but the new holder looks like it only has a flat cut on one side, not the other. So it is just a little bit bigger. Wait a minute, I might be able to push it in there. I just don't want to break the threads. No. Come on. It's like it almost wants to go, but I don't want to force it too much. Yeah. Crap. Alright, I may need to widen that hole just a little bit. Alright. Yeah, I think I'm going to have to do that. I'm going to try this. I don't know if this is going to work on this metal, but notice how I said it's flat on this side and it's flat on that side. The problem is the fuse holder, the more modern version of this, it's very similar, but it's slightly wider because it's only cut flat on one side. If I file this, I never tried that, but I could file some of these threads down flat here, and it might actually work. The only thing is that going to mess up the integrity of the bolt that holds it in place? I mean, it shouldn't if I do it right. Or I can try to cut the hole just a little bit bigger. You know what? I'm going to try the threads thing because this is like a $3 fuse holder. I'd rather screw up this. If it doesn't work, I can just go and open the chassis. But otherwise, what I was going to do is I was just going to take this nibbler tool and put this in here and just cut a little tiny sliver or two off of this side to make it wide enough for the new fuse holder to go in there. But yeah, let me try something. Let's try something new. I've never done this before, but I think if I make this flat, it should fit. Let me just double check. It looks like it'll fit. It's weird because it goes in just a little bit, but then it doesn't go any further than that. So you can almost see where the decoloration is right there. That's where I was forcing it in there a little bit. So if I make this flat right here, let's just see. Let's try something different. Sometimes being innovative. Alright, so I'm going to lay it on its flat side and use this little flat file. It's just plastic, so we're still going to have threads on most of it, but this will make the fuse holder a little bit more like the original, where it was flat on both sides. Almost there, I think. Hold on, just a little bit over here. See how I'm flattening that side just a little bit? Oops, sorry. Here, let me put this up just a little. So I'm trying to make it flat like this side. Look at that. Alright, now the question is, and make sure this is in all the way. Yep, it's in all the way. So that's actually very secure on that side. I just need to make sure the bolt will go on. There we go, and we'd have to cut the chassis at all or open it up. As long as this will go on. Hold on a second. Hold on a second. Put this on. Is that the right way? I think this is... shouldn't matter. Here we go. I think this is going to work just fine. It doesn't, the bolt feels pretty secure. I can't pull it off. I can't pull it back with my fingers even though I flatten that one side. I think this is good. Cool. So yeah, just flattening those threads just a little bit, gave it just enough to get in there really nice and tight and secure. Awesome. I'm just trying to see. This is where it gets tricky with these things, because might need to use a different kind of tool here. Let me do something real quick. Let me loosen this. Or actually, I'm just going to remove it for now. Just get it out of the way, this switch. Give me a little bit more room. It's just like barely enough room to get this thing on there. Alright, hold up. For now, I'm just going to do this. pretty tight as it is now, but I'm just gonna go a little bit more. Okay. All right, that's on there pretty good now. All right, crisis averted. And we didn't have to touch the chassis. I'm happy about that. Okay. I'm gonna go, actually, maybe I will put this back on. So we're just leaving this here for aesthetics. It's not going to be wired to anything. You know what you could actually do? Well, it's really not really much of a point, but you know how you can use the foot switch to turn the vibrato on and off? You could actually use this switch to turn the vibrato on or off. You know, you could leave it on all the time or turn it off by running a wire from the vibrato foot switch to here and then one side to ground, because the vibrato will not turn on at all without the foot switch plugged in and switching it, right? If you unplug the foot switch, you cannot turn that. That's why I tacked in one of these one of these alligator clips. So I basically taking the signal and I was just grounding it to the outside of the RCA jack. It could be grounded anywhere, really, anywhere to the chassis. But that'll make sure that when you turn the intensity up, the tremolo will be on. But you could wire a wire from here to one of these to ground and the other one to this, and you can effectively turn it on, have it always on, or you can turn it off. If you never use it, there's no point in keeping it on. You could burn out this roach light thing. You know, if you have it on all the time and you're not actually using it, that thing will still be blinking. So I think that's one of the reasons why they made it not on unless you use a foot switch. And the other thing you can do is, and I may do this later, because I don't think I'm going to do that with that switch right now. I'm trying to make this as original as possible, so I don't want to add anything I don't need to, right? But I'm trying to find a little RCA plug. What the heck are they? Alright, well, I can't find one right now, but what I was going to say was I can make a little RCA plug, like a little, what do you call it? Like a dummy stent sort of thing, where it's just the end of an RCA plug, and you just solder the tip to the outer case, and when you plug that in, it shunts it enough that you can turn the reverb on. Vibrato on without having the foot switch engaged. So I may make that for my friend and just give him that instead of running wires all the way across here to this switch. But yeah, I mean, you could use that switch for that, or you could use it for something else. But we're not going to use it right now. We're going to keep this thing original. Just wanted to tell you about that because I like to sort of teach in these videos so you can learn. All right, let's get to the wiring. So I'm going to run the hot wire to the back side of the switch, right? So we're coming straight from the wall. I'm sorry, not switch, the fuse holder. I'm going to run the back of the wire to the back side of the fuse holder. The reason is if you wire it to this side and the fuse blows and you forget to unplug your amp before checking the fuse, which you should always do, but let's say you forgot and you take the fuse out and you happen to touch part of the fuse, this side would still be hot. It would still be live. The side that's closest to your fingers on the fuse. See, if I take this out and my thumb right here touches this metal while I'm pulling it out, I could potentially shock myself if this is wired to this side, because this is the, there's two sides to a fuse, right? There's that side and that side. The one on the back side, if the fuse is blown, right, there's no power anymore, but you forgot to unplug the cord and you're pulling this thing out, then power can only get to this. It can't go through the fuse and shock you. So it's safer to wire it to the back of the fuse, the part that's coming in from the wall. Do you see what I'm saying? So that's why we're going to wire this to here. So I'm going to strip it. Actually, maybe just a little bit more. All right, strip it. We're going to tin it, because this is braided wire, braided copper. I'm going to put this under here so hopefully it'll stay, so you can see me solder it. Sorry, I know you guys can't see this. I'm just trying to tin this. Alright, so I want to get nice solder all over that. Let it soak into those braids. Okay. I'm going to just put a tiny bit here on where it's going. Okay, I'm going to push it through the hole. We're not done yet. Okay, now I'm going to bend this up flat against the fuse holder. Now actually, I think if this thing spins, which I think it does, I might just, so I already have a little bit of solder on the top, I might just solder it from the bottom here now. That way, so I'm going to heat up the whole component. There we go. Alright, so see how underneath here, it's very, I'm just going to trim off that little tiny bit. So that's all flat and soldered on the bottom side, and the solder soaked through to the other side as well. Okay. A little bit of the rubber got a little too hot. Oh, I should turn my iron down a little bit because I had turned it up for that chassis. Iron is a bit hot, running a bit hot right now, so to turn that back. Alright, so then the neutral we're going to send over here to the switch, because what we're essentially trying to do, actually before I do the neutral, let's just go ahead and finish this circuit, this part of the circuit. So there's two black wires here coming out of the power transformer. These are the primaries, right? It really should kind of be like a black and a white, a hot and a neutral, but it doesn't really matter. They're both black. You connect, you connect one to the hot and one to the neutral, and that powers the amp, right? There's only two wires there. There's no... Oh, that's a tough one. There we go. Let me snip off this part that was used before. Alright, so I have a nice clean wire to start with here. So this is one side of the power transformer. You see these two black wires? These are both the primaries. One needs to go to hot, which is going to go to the other side of the fuse. So it's coming in from the wall through the fuse to this side. So if something happens, the hot's going to get cut off right here. It won't go any further past here, right? So the hot is the line that, you know, in America it's 120 volts roughly. The neutral is 0, but you kind of need both to make the circuit complete, right? So that's why this amp works without a grounded power cable, right? I'm not going to cut this power, even though I could shorten this. I'm not going to, because if the shorter we make it, if another component, like let's say this fuse holder goes bad, we need to replace another one, we may want to cut a little bit of this wire off. We're just going to be chopping off inches of wire every time the thing gets serviced. You know, if that were to happen, then you might have to extend this wire. So that's why I'm keeping it long. It's not excessively long or anything like that, but I am going to try to keep it as original as possible. All right, so I'm going to go ahead and bend this out a little bit so I can just get my iron in there. The temperature of the iron is down a little bit now too, so hopefully it won't melt the rubber. And yeah, that looks good. And we can always check our connections by pulling on them. Everything looks good. I'm going to go ahead and bend this back a little bit. So that's through the fuse to the primary, to one side of the primary of the power transformer. See that? So that's what that goes. Now, because we have this accessory jack outlet, I should say. Sorry, I'm getting some extra wire here. Since we have this accessory outlet, I'll go ahead and, like I said, I'll go ahead and wire it up. I'll go ahead and wire it up, but you know, it doesn't have a ground. But just to make sure it does work, in case somebody does need it for something. You could charge your phone with this or something, you know, if you had a phone charger between gigs or you know, between sets or something like that. You know, it is convenient if you think of it that way. You're like, then I don't have my phone sitting on the ground. It could be sitting on top of my amp. I plug my phone charger in here, set my phone on top of my amp. Once we're ready to go, I'll unplug it, you know, because that can induce noise, having a phone charger and or a phone right next to an amplifier. But being able to charge it when you're not using it, kind of a nice feature, right? It can be used for something. It could be used for a pedal supply, yes, but it'd probably be better if it was grounded. Unless you had like a two-pronged pedal power supply, then hey, you could just plug it right in. I've used these before for like noise pedals. Like if I have an amp that I need to run for a show or something, and I don't need a pedal board, but I just need a noise pedal, I can plug in its power adapter here, set the noise pedal on my amp, and leave it on all the time, right? So it's good for that kind of stuff. I'm kind of old school. You newer guys, you might have all kinds of newer gadgets that you could plug into this stuff, but just keep in mind that it is not grounded. So depending on what it is you're using, there's always a potential for noise. So, all right, so now what I'm going to do is I'm running a new black wire here over to the little accessory jack. But see how I'm doing it from this side of the fuse? That way, if the fuse does blow, then power is going to get cut to this socket too. It has to go through the fuse, right? First. I mean, it would make more sense from a length of wire standpoint if I had just run this black wire straight to here and then over to the fuse. But I want everything to go through the fuse. If something's wrong anywhere around this amp, we should cut power as soon as possible. So that's what we're going to do for this. Okay, so all I need to do then is, this is the side that the hot was connected to, which looks like copper down here, and then this neutral's a different sort of metal. It's at least a different color. It's not the color of copper. Okay, hold on. So now we have a courtesy outlet hot. Now I'm not tinning this wire because this is solid core and it's not braided, right? So it just goes through there very easily. I'm going to give it a quarter bend, which is like a military spec way to do things. It makes it faster for you to unsolder if needed, that rather than coiling the wire around twice or something like that. That's always ridiculous. Don't do that when you're making solder connections in amps. Usually one quarter turn makes it enough of a mechanical connection that it holds it in place, but then it's also easy to unsolder and you don't have to deal with coiled up wires. That's always been one of my gripes working on amps, where sometimes they wrapped it around 2 and 3 times and I'm like, why? It's just an excess of crap that now is a pain in the butt for anybody to get off. Alright, so there's the hot from the fuse, okay? So now we have that connected. Now we'll do the neutral, and then we'll do the ground last, because that's going to be a new dedicated earth ground. So this one we need to go to the switch because the other side, the other black wire here, is going into the transformer. So this is the other side of the transformer, the neutral side essentially, right? So this is the hot side, which is connected to this side of the fuse, and also our courtesy outlet, and then this side is going to be our neutral over here. So I'm going to go ahead and looks like I gave myself just enough wire here. Go ahead and strip this. Oops, sorry. I'm trying to not strip too much. There we go. Alright, so this one I am going to tin. So when it's braided stranded wire like this, it's always better to tin it for two reasons, at least I think. One, when it's braided like that and you push it through a hole of any sort, sometimes it bunches up and gets crinkly and it's not straight anymore. So you've got little extra strands kind of poking out of the sides and things like that. You know, it's just not very clean, and then if they break off, then you got little strands of wire inside your amp floating around that could cause a short. You know, that's one reason. Another reason is it's kind of nice to pre-soak these in solder so that solder gets all down in there, and then it'll make a better connection once you're connecting it with the component. So the component we're connecting it to is this, so I can just push it right through there because that solder glob is nice and hard and secure now, right? It's not going to fray on me when I push it through there. So I'm going to push it through. We're going to do the old quarter turn, just turn it up, giving it a little bit of a mechanical connection. I'm actually going to try to bend it like that. So it's going around and hooking around the side. And then I just need a little bit of solder to solidify the two pieces together. There's already a little bit of solder on this switch, but now everything together should bond that really well. There we go. Alright, now what I might wind up doing is like putting a little zip tie on here so that all this stuff stays nice and tucked up under here. Matter of fact, might do that now. Let me see something. Yeah, if I put a little zip tie here, it just keeps everything a little bit neater. I'll do a little bit more cable management type stuff once I'm done this, but yeah, so that's pretty nice. Okay, so now we've got the neutral taken care of. There's only one other thing we need to do, and run neutral back to this accessory outlet here. So I'm going to use white for that. See, they were just using the yellow wires here. I'm trying to keep the color coding kind of the same as the electrical cord so that visually you can kind of see where things go and it makes sense. All right, so I'm just going to hook this around because I don't think that there's enough room to put this cord and this through there. But if I hook this on like that and solder it, should be enough of a mechanical connection to hold it in place. The holes on these switches are very small, and the power cord wire is so thick that I don't think there's any way I could get both of these through the hole. But yeah, that's good enough. That's nice and solid. Yep. All right. So now the neutral's going to be on this outlet. The neutral's always going to be connected. The white wire. Meaning it's always going to be like on the socket. But what happens is if the fuse blows, then there's going to be nothing getting to the hot here. So it'll just kind of make this a little bit safer. I mean, again, whatever you're plugging in here is not really affected by the amp circuit at all, but it is affected by the fuse. So at least this is a fuse protected outlet. So if you plug something in here that you really shouldn't be plugging in here, then it'll blow the fuse, right? So at least it's protected that way. See what I'm saying? It's not a grounded socket, so more protection the better. There's lots of ways that you can do this, and I'm sure there's somebody watching this that might be arguing the way I'm doing it. I'm just trying to think as logically and as safely as possible. But yeah, I mean, if you have any doubts of the way I'm doing it or why it's not good, feel free to leave a comment. I love criticism. I like learning. I won't dismiss your claims. I won't be like, oh no, you're absolutely wrong. I'll take it under advisement. We're all here to learn, and if we can help each other out, that's great. All right, something's going on here. I think it's because of this cloth. I can't seem to make a good connection. For this one, I might need to angle this over just a little bit more than a quarter turn, just because it won't stay. Sometimes if you take a little wrench and you set it like in there, then you might be able to get your it to stay in one spot and not move as much. That's what at least that's the idea I'm trying here. Trying to heat up the underside of this. I think the problem is that I'm soldering from underneath and the gravity is pulling the solder downward. But I think I just got it that time. Let's see. Did we get it? Yeah, I think so. Here, I'm going to do one more thing here. I'm going to pull up on it and hold it while it solidifies. Okay, that should do it. All right, so if you need to check your work, push on things, pull on things, make sure they're not going to pop right off. It's always good to check to be sure everything's secure. It should not just pop off. If I take these pliers and just yank on a little bit, it should not come loose, right? Any of these connections. Everything seems really good. I might actually put just a dab of fresh solder. I am going to hit a lot of these solder joints just because a lot of them in this amp they've been around for a long time doing their thing, and sometimes they can crack. Solder can get weak. So hitting them with just a little bit of extra new fresh solder can be good. I just put a little extra right here. Okay. All right, that's good. Well, while I'm at it, I'm going to hit this standby switch too, just with a little fresh. Actually, I'll go ahead and, since I got a solder vacuum, essentially, I'm going to vacuum up a little old solder and put some fresh on. So one of the things that a lot of these amp companies didn't do a lot of back in the day is clean the old flux off of their solder connections. They put flux on. Maybe they were using leaded solder that didn't contain any flux back then, and they put flux on to make a good connection, but they never cleaned any of it off with alcohol or anything, or acetone, or anything like that. So the brown stuff you see around solder connections is usually the old flux, and that stuff is somewhat corrosive over time. I mean, in an amp like this, it's not as worrisome. It can corrode things. It's a very slow corrosive. On big tabs that you're soldering to, like this stuff, it doesn't matter as much as it would if this was like a circuit board amp. If this was a circuit board amp and they left a lot of flux on there, I've seen flux destroy amps over a decade or two, just sitting on there being left alone, and it's starting to bubble up and crystallize, and then traces and stuff on those circuit boards have lifted. You know, I've worked on a lot of amps like that, and I'm like, gosh, this would have been nothing. They wouldn't have had any problems if they would just took a little alcohol and clean these connections afterwards and remove that brown stuff. I don't know if you can see it here, but like on that, see it over here on this, it's so caked on there. On that polarity switch. So look, all they would have had to have done is take a little bit of isopropyl. Oh, there's so much flux on this one that it'd probably take a little bit of scrubbing actually. But yeah, I mean, look at all that. It's almost completely gone now off of that. But this has been sitting on there for 60 some years, 62 years, you know. But look at all that. Oh, it's really dirty. I may go through and clean up some of these, you know, at least on the main stuff. Power switch, the standby switch. These are things that you use every single time you use the amp, you know, and these are really good high quality switches. I mean, they can last a lifetime. I mean, these are like definitely, they make so much cheaper plasticky switches. These are, you could hit these with a hammer and they'd probably hold up. But you know, if things are corroding, that corrosion could cause them to get weak, fail. Maybe one of these tabs gets weak enough that it pulls out of its spot and now the switch isn't effective anymore. These are like industrial switches, man. I love these switches. I think these are like the Carling. I don't know if Carling actually... Yeah, these are Carlings. I still buy and use Carling switches today. Yeah, like for example, here's a replacement of one of these guys. It's the same exact thing, but this is a Carling, and it's freaking just as reliable and well made as it was back in 60 years ago. So very, very good stuff Fender used on certain things, and obviously they had to cut corners on some other things and use some cheaper stuff, but for the most part, the stuff that they knew would wear out quickly, like switches, you're going to switch these on and off every single time you use the amp, so they should be good quality. If you put a cheap switch in there to save money, it's just going to cause problems. So anyway, it's good to clean this flux off, even if it is old components like this. I'm kind of a stickler for that. It's more important if this was a circuit board amp where things could get really corroded and messed up. Now, I've even seen like resistors get weak sometimes because there's so much crusty flux on the end that the lead just pulls out of it. So I don't know if that was the flux or heat that you caused it to get weak and collapse, but I've seen it. I mean, be like there's an open resistor Y and I pull on the lead and it just literally just falls out of there, and I'd notice how much crusty, nasty flux is around that area. It caused the carbon on those resistors to get weak, I guess, and now the lead pulls out of it. So it can do damage, but we'll go through and clean a lot of that stuff up too after we do the rest of the servicing. All right, on to the last piece of this, and the most important piece of changing the power cord and updating this little power section. We've got a new fuse, just in summary. Power switch is wired up. This outlet is wired up. It's a little bit safer than it was, and it's still, you're still able to use it, right? And now we need the ground connection. So let me get set up to do that. All right, time to do this earth ground. So in traditional Fender fashion, Fender usually grounded, especially a lot of places in this amp, they grounded things straight to the chassis. You can see that little solder glob under there. There's a ground connection coming off of this bias board over here. That's where we're getting the negative bias through this filter cap. Anyway, I know you can't see that, but there's a little filter cap under there. So yeah, they did that all over the place, but in order to solder to a chassis, you need a lot of heat. I mean, a lot of heat, more than your standard run-of-the-mill, even really good quality soldering iron like this one is. This is a HOW-TO. That's my normal iron. Now my desoldering gun I had been using, this guy, this gets a lot hotter than that other iron. I can set it a lot hotter. So that might work, but it's just not enough surface area. So if you really want to do this right, soldering, you need to get a bigger iron. So I've got this Schnalzeramus. If you guys ever watch Terry of D-Lab Electronics on his YouTube channel, he's got one, a really big one, bigger than this probably, old school, but this might work. So I'm heating this up now. This one takes a long time to heat up. And what I really would prefer to do, I don't really like to solder to the chassis, because I've had too many times where, if you see this guy right here, let me point it out. This guy right here, it's like, it's on there, yeah, but I bet if I apply a little bit enough pressure, I could just snap it right off of there. It's not well formed on there. I don't know. It to me, it's a lot more prep, and I feel like it's not as much of a mechanical type connection, like if we had like a screw or a terminal or something that we would solder to. So my inclination is to drill a hole and have a little terminal strip that the ground gets soldered to, and then have a bolt, and then maybe even solder a little bit around that bolt. But I'm not going to do that because there's not a lot of room here. This transformer actually on the other side comes out like a half an inch on each side. So I can't just drill on the side of the transformer here. And if I drill too far to the side of the chassis here, that's where the wood is, where you slide the chassis into the amp. So I'm going to try in true Fender fashion, try soldering to the chassis. But one thing we need to do is prepare the surface if we're going to do this. So one is I need to clean the surface really well first. So I'm looking for my, where's my attachment for my, I seem to have lost my attachment for my little vacuum cleaner thingy. Hold on. It's got to be around here somewhere. Oh, here it is. Alright. So I'm going to vacuum this area up, but before I do that, actually, I'm going to go ahead and scrape away. I'm just going to try to use this wire brush. I don't know if this is going to work or not. A little area over here where we can have a dedicated ground. Now, some people might say, well, why don't you just solder to this other solder glob? Or why don't you, you can even put like some kind of a thing around, like a terminal around the bolt where the transformer is being held. Yeah, I could. But a lot of people kind of stray away from that, because what can happen is, let's say the amp took a little fall. It was in the back of a truck or whatever, and it falls out. The weight of the transformer is so heavy that you could snap a bolt or something like that. Like I've seen that happen before. A bolt could get snapped or whatever, and if you're relying just on the tightness of that bolt, this is your earth ground. This is probably the most important connection in the amp right now. So that bolt could snap off. So I like to have a totally dedicated, meaning nothing else goes to it. There's nothing else, it's just for the earth ground. You don't put anything else on it, just earth. And that's also safety code nowadays. Earth should have its own ground. So that's why I'm going to take a brand new open spot where nothing else is, and we're going to solder to the chassis. That's just kind of how I'm going to do it here. And also it's good practice for it to have its own thing. I'm not opposed. I'm the kind of person that, like, I'm not opposed in most cases having a little terminal where the transformer is held onto. I've done that before, but you know, it depends on the amp. If it was a really small amp and the transformer's not very heavy and the chassis is really good, high quality, it's not going to bend or break, you know, at least the likeliness. I've done that before, especially if there's not a lot of room inside of an amp. But here we got plenty of extra room, and what I'm trying to do is I'm trying to rough up the surface and scrape away any coating that might be on this metal. Because if you leave and you just try to solder straight to this coating, because it does look like there's some kind of coating on here, your solder is definitely not going to bond. So we want to go down to bare metal. So I'm just trying to scrape away a little bit, and then I might sand it. So yeah, I'm just trying to go around. You can see it's already starting to change color a little bit because we're getting down to bare metal. And it's a good thing that it's not smooth. You want it to have little scrapes and stuff because that'll help the solder seep into the little cracks and it will give it a better bond. But yeah, we're getting down to bare metal here. It's looking pretty good. I'm gonna take a piece of sandpaper and just, this is a little bit more rougher than that brush was, so this will create some good scrapes. Yeah, that's looking pretty good. And I don't want all my lines going the same way. I'm gonna kind of go different directions. So I think this looks pretty good. I'm just making it big enough so that if my solder does flow outward and spreads out, that I've got enough room for it to seep into all those cracks and everything. Alright, so now let me just vacuum a little of that dust up. Okay, here's another thing. Normally I would, for cleaning the chassis, I would use alcohol, isopropyl. In this case, I'm going to use a little bit of acetone because both of them are good. And alcohol will work just fine, but the acetone, I feel like, helps to get up any oils, and it also evaporates even a little faster than alcohol. But basically I'm just trying to degrease any particles of grease, or you see it's a little dirty and it's already evaporated. It evaporates so quickly. And I'm using a microfiber cloth because a paper towel sometimes has that dust. I don't want anything around this area. I don't want any dust, particles. That's all. It's like some stuff still coming up off of there. It's probably the surrounding area. So should be fine. Okay. Yeah, so Snozeramus, I think, is feeling very hot. So I'm gonna, the other thing I'm gonna do is I'm gonna put some flux down, because this is a very important connection to make a good bond, and the flux will help to prepare the surface. It will help to spread the solder. Sorry, I'm just looking for a little. This should do. So I'm just going to use this flux paste. This is the stuff I prefer to use. Sorry, I'm trying to get it in there. SRA rosin flux paste. You could use a liquid flux. Can be pretty generous about this, but the more you use, the more sort of smoke is going to happen when it gets hot. I'm just going to go ahead and swirl that around with my hand for now. Alright, and another thing is, I haven't been doing this very much in my videos lately, but I should probably do it now. I'm going to get my, this is just a little exhaust fume fan that I'm putting back here. Something that I made out of a little fan that I bought. So you can buy these fans. It's a little bigger than a computer fan. Well, a lot bigger. Oh, darn it. See, I've got no room here, and I'm stepping on stuff. Sorry. But basically what I did was I put a carbon filter in here, and I'm just going to set this here because there will be a lot of fumes, and we're going to have to hold it on there quite a while. So let me see if I can turn that on. This is like a clown show. I can't okay, hold on a second. I'm gonna knock something else over now, I'm sure. Hold on, hold your horses. Okay, here we go. Sorry, I had to find the plug for that. Okay. I can feel heat coming off of that iron from a foot away. So it is quite hot. Alright, now what I'm going to do first is I'm going to go ahead and put some solder down on that spot. I'm going to try to find you a good angle. Now, can I get this flat? That's the problem, without burning up any other wires, because this whole thing is hot. Well, I may need to move some things, because this is a big iron. If I could get it under here, but then I might have to pull these wires up. Give me just a second, guys. Guys and gals. Alright. If I could get this under... Oh, shoot. See, I'm already melting these wires. Trying to make like a little bridge here. Alright. I don't know. I'm going to see if this will work. It's a lot of area for... You see how the solder's balling up on the iron, but it's not flowing onto the surface of the chassis? That's because this area of the chassis really needs to heat up, and it's going to take quite a bit of some time. To get that whole area hot. I'm just trying to keep an eye so I don't melt these wires, because this iron is very hot. Okay, that's starting to work. It's starting to flow. Matter of fact, I'm just going to try to... spread this out a little bit. And then I'm going to come back and put our ground wire in it in a minute. Alright, let me take this out. Alright, I think that's gonna work, but now I gotta strip the ground wire, and I'll go ahead and trim this back a little, because it is a little long. It doesn't need to be quite that long. Okay, so we're gonna tin this, and also I might want to put a heat sink on this so I don't melt up the rubber on the outside. Yeah, that sucker's pretty hot. It heats up and heated that up in a flash. Oh, I'm so sorry. I'm trying to work in a small area and you didn't see that. But yeah, I just tinned the end of the ground wire and stripped it. Okay. So now what I'd like to do is I'm gonna see if there's a way that I can what I mean by a heatsink is if I could put something like this pair of pliers against here while I'm soldering, then the heat will travel through the pliers and not so much up the rubber part here. Otherwise we're gonna melt that wire. It's just gonna be really hard. I don't know if I can get this to set there. Hold on, I got a heavier pair of pliers here that might work. I'm trying to give myself enough space for this huge soldering iron. This thing's massive, so it's gonna take up a lot of room. I need this to be down here, but you know what? Maybe I could hold on a sec. I have this metal block. If I could set this on it, let me just see if I could do this. If I could set this here, then the metal block will absorb the heat, hopefully, not melt the rubber, at least not as much. I'll keep it on where I need it, and it's pretty heavy, so right, see what I'm doing there? I'm just kind of setting that on there. So hopefully the heat from the iron will get absorbed into the block and not go up the strands and melt the plastic. At least that's the hope. Alright, so we have solder on both sides. I'm going to be very careful here to try not to. Hold on, let me just clean that off just a little bit. Tin the tip here a little bit. Okay. All right. All right, let's see. Now we're going to add some new solder to mix with the old solder. Press down on this. Alright, now it's flowing. See how it's starting to sort of spread out a little bit and flow? That's how you want it. Okay, let's see. Okay, I'm gonna let that. It's gonna take a minute to really solidify. May have already solidified. Alright. Okay, let's see. Oh, that looks pretty good. Okay. Didn't melt it like too much. Alright, you know, I have a little bit extra here. I don't know if I can snip that off. It really doesn't matter. But the key is, did we make a good connection? Let me clean this up a little bit. Alright, now I'm just going to clean this up with alcohol. And get rid of that old flux. So see how there was like a little brown pool of liquid? That's all that flux. And like I said, Fender didn't clean any of that stuff off of their connections. And that's what gets all crusty and brown over time. Now, did we get a good solid connection? I should be able to pull on that fairly, you know, fairly strong and have it not come up. Let's see. Yeah, I'm really yanking on it. Alright, I think we're solid there. I think it's spread out enough and bonded with that surface enough that we should be good. Alright, earth ground taken care of. Can't pick it off with my fingernails. Can't move it, pull it up. So yeah, this is, I'll see if I get you a different angle, what that looks like. It really just takes a lot of heat to make this successful. It's a little more solder probably than I needed, but it's spread out and it seeped into all those holes, and I can't pick at it and pull it off and yank on this. I'm pulling really hard and it's not coming up, so I think we're golden. One thing I might do here, and I'm just going to do this really fast because I don't want to burn up that wire, but I could just going to see if I can put just a teeny bit of solder on those exposed copper wires right there, just to cover them and make them so that everything coming out of that rubber shield there is covered in solder. Just have less of a weak point if somebody does pull on this. So, okay, I think we're good. So that's earth ground. Again, I would have personally felt a little better drilling a hole, putting a screw and a tag and a really nice like nylon locking nut or something, and having a dedicated screw, and then maybe putting a little solder around that what do you call it, solder lug, you know, like all we would have needed was something like this. Sorry, I'm trying to get one for you so you can see what I'm talking about. Something like this, like a little solder lug. We could have drilled a hole, put a screw through there so it's mechanically connected and bonded to there. Tighten the screw, solder the ground connection to the tab, and then even we really at that point really don't need solder at all for the base, but we could have put a little solder around this base, and that way it's soldered to the chassis and it has a mechanical connection. This is just soldered to the chassis, but it feels tight enough and secure enough that I think we're good. I can't pull it off with my hand unless, I mean, I didn't yank it absolutely as hard as I could, but I was yanking pretty darn hard and it wasn't coming up. So that's how you know you got a good bond. If you didn't have enough heat, I've had times where I've done it and it wasn't enough heat, I could just lift it right off and it would click and the whole glob comes off. So if it doesn't come off with a decent amount of pressure, you're good. And then you're not relying on these bolts of the transformer in case something falls and the weight of the transformer pulls on it and the bolt cracks off. Then your earth ground is no good, and then you plug the amp in and you have no earth ground, right? So I think we're pretty solid there. Alright, let's go ahead and can put these wires down now. Since I bent these a little bit, I may wind up touching these up, these solder connections up. And I haven't cleaned the sockets yet either, so. Alright, well let me put the heavy duty soldering iron away because I don't need that. Clean up a little bit and I'll be ready for the next section. We are set up to do the cap job change, at least part of them. These are the main filter caps, right? This is what's under the doghouse. Now, remember, as I mentioned at the beginning of the video, unless you skipped ahead, these caps have been changed one time in their life. These are not the original caps. These are caps that were made in Japan. I'm not sure when. I don't know if this is a date code, if this is the 36th week of 1962, but these are 30 microfarad at 450 volts, whereas the amp schematic says they should be 16 UF at 450 volts. I'm just going to see. This should be the same. Yeah. So whoever did this, they didn't put them all facing up, which can help sometimes. And the other thing I noticed is they used an awful lot of solder. If I take you down to this angle, let's see if I can show you this. There's some really big solder globs under here, and that's what's making the board warp to some degree. There's just massive globs of solder under there. So I'm going to try to use my desoldering pump to try to suck out some of that solder. And I'm also going to probably change these resistors. One of the things I wanted to try first, though, is just test them to see if they've drifted at all. They should be 10K in value, but, you know, these things will drift over time. Now, these are like the position that they're in. They're like dropping resistors, meaning they're going to drop the voltage down at each stage of B plus voltage, right? These two are actually connected together on the positive, and then these are independent ones. And there's a wire going from one of these here to, you know, one of the main, probably connected where the choke is connected in one spot, and then this goes off and connects to its own section, and this connects to its own section, that one connects to that its own. So and if we look at that on the schematic, just so I can show you, I don't know if you'll be able to see this here. Over here, these are the two 16 UFs that are connected, two 16 UF 450. Let me turn the brightness down. Maybe there we go. So see how those two, the positives, are connected together. That's these two guys right here, because I can see that they're still connected underneath. So at least when they changed them, they did that right. And then here's the standby switch, which goes straight to the choke. Sorry, right here. And then there's another 16 UF. That'll be the next one in line over here. Then it through a 10K resistor, which is this guy right here, to the next one. And then there's another 10K resistor here. So what these 10K resistors are doing are they're dropping the voltage down, you know, a certain amount of volts. I'm not sure how many, but it doesn't, I don't think it shows the voltage here, but let's say at this point it might be like 400 volts here, standby switch, then over here 400 volts probably, and then I'm just guessing, I don't know what the exact amount is. Then when it goes to this 10K, it probably goes down to like 330 or something, right? And then it goes down again. Now over here, by the time it gets past all these resistors, then it's down to 260 volts. And that's what's going to supply some of the high voltage needed for the preamp tubes. So actually here it is, 310. It does show you the voltage. Here's 310 over here. I don't know why it's not showing you the B plus voltage over here, unless I'm just not seeing that. But yeah, so they're dropping. So that's why those are so large compared to the other resistors that are in the amp, the smaller ones. These are probably 2 watt. I'm guessing. What I'm going to do is put some 3 watt resistors in there that are metal oxide, and they can take heat a lot better. I could probably put some 5 watt resistors, like cement wire wound 5 watts in here, but I don't think that's needed in this case. The reason why the wattage, you know, they're bigger and they have more, they can handle more watts, is because it is such high voltage and they're dropping that voltage down, they're going to get hot. The heat has to dissipate, the energy that's being reduced has to dissipate somehow, and that's through heat. So I do notice that this one is quite crusty here, and this one looks okay, but this one at least is starting to get a little discolored. This is actually the first one that drops, so this one's going to take the most heat. Now, back in the 60s, these carbon composite based resistors, they're not that great because their values aren't always, I think they're within 10% or 20% tolerance, which means right out of the bat they might be actually 9K or 11K, something like that, right? But then they might drift over time. So I'm going to see if these have drifted at all, which means usually they drift up and they get more resistive. And the more resistive they get, like let's say this is 15K now. Now it's going to be dropping the voltage even further and more heat's going to be coming off of it. So over time, they're going to get hotter and hotter and hotter. Well, these metal oxide resistors or a wire wound based cement resistor will handle that kind of heat a lot better than these carbon comps will. So even though this is about the same size, this is actually another watt higher. This is a 3 watt and these are 2 watt, I believe. So let me see if it says it on there. No, actually they're 1 watt. They're 1 watt. Yeah, it says 10K 1 watt. So they must be half watts. The smaller ones are half watt in the amp. These are 1 watt. So these are either 2 or 3 watt. Now I'm wondering which, but I know they're not 1 watt. They're higher than that. So they'll be able to handle even more heat, but just because of the metal oxide component to them, they handle heat a lot better than these carbon comps. So we're going to go ahead and replace them because we do not want these to fail. Let's see what they are. All right, so I'm going to set my meter on 20K. Put it somewhere where you can see it. Oh, hold on. I lost my lead. I'm not sure if this is the right lead for this or not. This doesn't feel right to me. I think I must have taken this out. Give me a second, guys. I'm going to try these because I have a lot of different test leads for different things. These are the ones that are like alligator clips, so I'm going to see if they work. These don't work on that type of meter. Where's my other guy here? Let's see if this will work. Alright, hopefully this will work. So I'm going to try to measure using this LCR meter. I'll make that bigger once I get to soldering so you can see, but let's see if I can get a reading off these. Now they are in circuit right now, so okay. 10.27, almost 10.3. And this one's 11.06. Now, I don't know if that's drift. Remember, these are supposed to be 10K. I don't know if that's a little bit of drift going up, or was this one just a little bit higher when it was made? I don't know. The other thing we should check is take them out of circuit, because sometimes you'll get a different reading. So all that means is try to lift one leg to take it out of circuit. Okay, lift that one. Okay, let's test it now. I'm just curious, is it going to give me... It might be the same, but we'll see. Alright, so this one... Okay, instead of 10.27, it's a little higher, 10.47. This is its true value now. 11.2, roughly. Yeah, so the fact that it's a 1K higher roughly than it's supposed to be, that's not going to make a huge difference in the amp. But let's take a look at what these guys are reading. Make sure I have the right value first off. Yeah, 9.96. It's definitely closer than the other one is. And that one's 9.92. Yeah, it's fine. So within a 1K. All right, so let's go ahead and get to changing these guys. It's a pretty easy process. Like I said, Fender made things very easy to work on. I mean, That's one thing about their amplifiers that I've always really liked, is that these old Fenders are a joy to work on compared to the new modern day circuit board Fenders. Those are real pain in the butt. They're not as bad as Mesa Boogie or like Rivera and some of those other amp companies that make it pretty hard to work on their stuff. But yeah, so let's go ahead and take these 10Ks out. I'm really doing this for safety. This isn't going to change the tone of the amp or anything like that. These are really power supply resistors, and they're supplying all the other components that need the high voltage in the amp. You know, the other tube plates and things like that that are going down the line. Okay, got rid of that guy. Just get these out of here while I'm doing this. Sorry. I'll remove some more solder as well as I go along here. Let me brighten up my scene here with the light again. Okay. All right. Another thing I want to do is take off that screw, because I do want to just check underneath here. One, I want to look for, don't always assume that everything's okay. If you're doing this, you want to make sure there's somebody didn't leave like a lead in there or something. If I can, well, I can lift it up enough that I can tell, and there should be another one over here. I just want to make sure there's not like a piece of wire or something that could move around and get under there and short something out, because we're talking about high voltage at this section. Alright. Now, it's going to prevent me from lifting this up too much because of the wires that are connected to the board. But if I can just get it lifted enough to see underneath, that might just give me enough assurance that we're okay. Yeah, it looks pretty decent, and I'm going to go ahead and remove the caps. Let's just get them all out of there, and then I'll take another glance under there, but I didn't see anything. One thing that might make this easier is if I just snip them all out and get rid of the lead. Whoops, that one's still pretty hot. Okay. Now this will be a little easier to work with. And there's definitely some leads sticking through here. I'm going to resolder all this, so that's why I'm getting rid of the solder, some of it. Yeah, now I'm not going to get rid of this because I don't know if you see this little one sticking up right here. Let me make this a little bit bigger. Because there's a wire connecting these two caps together, the positive end of both of these two caps up underneath. That's what this is right here. There is quite a lot of solder glob under here. I wanted to try to get rid of some of that just because it's pushing this board up so far. Oh, it looks like they might have left the lead of one of the other caps in there. That's why there's a big solder glob. Let's see if it's this little guy right here. Come on. to get him out of there if I can, but it's just... Hold on a second. I don't know if it's the bigger one or the small one. Hold on. Yeah, the bigger one is the bridge that goes across. There's a little guy in there somewhere. Alright, well, I'm just going to leave it for now. I don't know if you see some of this little bits of solder here. It's just, it doesn't need to be all globbed up like that in there. Okay. So I'm going to leave this and just see if I can't. Suck out some of that extra solder. Whoops. Hard to kind of suck it out if it's lifted up like this. Alright, I'm just trying to get rid of all these old leads. Okay, I can't remove all of it. Trying to make that focus for you a little bit. Can't remove quite all of it, but this needs to stay, that needs to stay. These guys all are just going down inside. I'm going to clean these eyelets up a little bit too before we put the new ones in. But now I just got to remove these from the back here. Actually, it probably is easier just to clip them out and grab the lead so that I get the bulk of them out of the way. Remember, these are not going to be used again, so they're getting thrown out. Capacitors do have a shelf life, and you should not be using old capacitors. That's another thing that I've seen on eBay a lot that you got to be careful of, is that for electrolytic capacitors, I'm not talking about all capacitors, but for these kind, for the ones that have electrolytic fluid in them, you know, they have a dielectric, they have an expiration date, you know, 15 years or so. I mean, it's not written in stone. I mean, sometimes you could have 50-year-old caps and they're still potentially functioning, but they really should be changed, maintenance, if you're going to be using that piece of gear and you want it to be safe. You know, every 15 or 20 years, maybe 10 years, you know, if you really want to be proactive about it. But I see a lot of times people listing vintage capacitors, you know, like it'll be vintage electrolytic capacitors from made in the 1950s or 60s or somewhere around that era. You know, who would buy that? Because even if they're sitting on a shelf, they're wasting away. Like, even if they're not used in a circuit, that dielectric is drying up and it's going bad just sitting on a shelf. So they have a shelf life even if they're not being used. So just be careful. Like, I would not personally recommend buying any new old stock electrolytic caps and thinking you're getting something good for your amp, because you're not. More than likely they probably have already failed before you even put them in there. So now, on the other hand, like things like tone caps and all that are non-electrolytic caps, that's a different story. Most of those should be fine. Like these blue molded caps, that's why I saved that DeathCap. Some people like these blue molded caps. They can still potentially be used. You could use that in your guitar, right? Be used in a lot of different ways. Alright, we got that cleaned up. I'm just gonna... Actually, let me just check something here. Make sure I'm not... I'm just emptying out my little canister of solder to keep it clean. These guns are amazing. I mean, they are a little expensive. Matter of fact, my really good friend of mine, one of my best friends, that this amp belongs to, he gave me this. He's the person that gave me this desoldering gun. He, I think, had bought it for something, just wasn't using it enough. He's like, hey, you get more use out of this than me. And at first I was like, nah, I don't need that. I've got other ways to desolder stuff, right? Solder wick. I've got this solder pump. But I tell you what, this thing sucks. These things are horrible. I mean, there are people that use them that can do it right, but I find that they just, you got to heat the solder up, you got to move over, you got to go like that. And I mean, look, it never works. It takes me 10 times longer to do anything with one of those. And solder work is great for, circuit board work, something more intricate. And sometimes if I need to get something really far down in there where this can't go, sure, solder wick is great. I just do not like using these little manual pumps. They don't create enough suction a lot of times. I mean, some people are really good with these and they can do a pretty good job, but I suck at them. So this thing has been a lifesaver, and it's my favorite tool of my shop. I use it all the time. And if I ever break one, I'm going to go out and buy a new one right away. If I break this one, just because I use it so much. Alright, so I'm just bending over these leads. You'll see that I took all the leads of the caps out, but what these leads are for here are... They're connecting, this black wire is a ground connection for all the caps, for all the negative ends of the caps. And somebody put like a wire from here to there, and then another wire from here to there, and another wire from here to there, and so on, to connect all of these down the line. And then there's a black wire right here. I gotta see, why do they have two black? Oh, maybe, I think I know why. They're using the same ground for these three, and then these two have their own ground, I think. I think that's why. But if we check continuity, all those ones on the back there should be... Let me just check, see if... these should all be ground. Hold on. I got this new meter, so I got to figure out how to... There we go. Put it in continuity mode, so now if these two leads touch... here and here, it's gonna beep, right? So I want to see, is this ground? Yep. Here, let me just put this in this hole. Ground, 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 ground. No ground, no ground, no ground, no ground, no ground. Cool. But this should not be connected to this or this. Let me move this back. These two should be connected together. Yes, that means there's a wire underneath that's running across. But this one should not be connected to that one, or this one, or this one. And these three should not be connected because these resistors are what are going to connect them together. Okay, so I just wanted to make sure all that continuity is still the same. That means all the wiring underneath the board is working as it should, which is not a lot. It's one wire from here to there, one wire from here to there, and then this, and this are all connected as well. All right, so let me clean this up. Just take a second here and take some alcohol. Just gonna wipe the board off, and really what
what the main thing is just to clean these and to try to clean some of this old flux off of these, because it'll make a better solder connection for these new caps. There's quite a lot of flux back here. It's already looking a lot better. Just getting all that black crusty stuff off of there. That's one thing that a lot of people don't do, is the cleaning parts of this type of job. But you know, when something looks like this, sorry, let me see if I can get it to focus. See how crusty that is? I mean, that is not you can add more solder and you can create a glob, but it's just not going to bond well to the eyelet itself and be anchored in there as well, unless you can get down to bare metal. Now this one's going to be a little tough. I might need to kind of scrape this a little bit. That works pretty well, actually. That definitely removes some of that crustiness. See, now the eyelet looks so much shinier now. Should make it a lot easier to solder to. Alright, so now I'm just kind of going over to get all that dust up that I just scraped up. Alright, go around here. When you see me put my hand in front of there like that, I'm just trying to make it refocus, because I'm noticing on my monitor across the room here that it looks like it was out of focus. Alright. Almost ready to put these new ones in. Just gonna get rid of this dust and dirt and debris that just came all out of this thing. Alright, a much cleaner surface. The board is, yeah, it's a little warped, but it's totally fine, and the integrity of it is still good, so does not need to be replaced. I'm just taking one more look in here before I start installing stuff, in case there's something I need to remove, or and it is a little dusty under there. Not that that matters too much, but I'm just trying to keep things as clean as I can. That's a lot better now. Alright, we're looking good. I'm gonna keep these screws out of it until I'm done, because that way if I do need to lift this a little bit while I'm soldering, I can still do that. Alright, just wanted to straighten up my angle here so you can see. Alright, so again, all 16 UF caps are going in here. We're putting this totally back to original. So we got brand new F&T at 475, so their voltage rating is even higher than 450, which is totally fine. Matter of fact, it's better. It just means that if there is higher voltage than 450, for some reason. I don't expect there to be, but in this amp. But, you know, we could get up to possibly 430 or so. These caps are rated for more. Voltage. All right, remember, positive end's always on this side, all of them. You have to be careful with these Fenders and don't always assume that they're all on the one side, because there are a lot of Fender amps that have the 5 caps under the doghouse, and one of them is facing this way, and the rest of them are facing the other way. So you just have to be careful, because these are polarized caps. This is the positive side, this is the negative. On these particular caps, the positive side is labeled with plus signs, and there's usually always this little divot on the positive end, right? This is the negative end down here, so the plus signs are on this. Sometimes there's caps where, well, let's take a look at these ambassadors. Oh, well, this is cool. They actually have plus here and minus here. I don't know if you can see that. Plus here and negative there, but it also has that little divot here on the top where the positive end is. So always make sure you're installing these correctly or they will explode. Alright, so what I want to do here is, how much do we need? I'm going to try to cut off, if you look at this, if it's supposed to be laying flat, we need at least that much and a little more. So I'm going to try to get them cut down to about where there's about 1/4 of an inch. Doesn't need to be a lot, but like 1/4 of an inch past the body of the cap. Something like that. Maybe even a little more. Okay. Alright, so for this one, I think what I'll do is, oops. Again, I'm just going to use for now, let me see if I can give you a different angle here. This camera is just constantly in my way, but I did want to have a close-up view for you. Let me see if I can. That might give me enough room to work and be out of the way. Alright, so I'll go ahead and heat this eyelet up, give it some fresh solder, push this down in there. I'm gonna take a look at that again in a minute, because that was yeah. Sorry, I gotta figure something else out with this. Apologies again. I'm gonna try not. That time I actually hit the cord for where this camera is with my foot, and it knocked it over. Alright, so I will secure the back end here by giving it some more solder and pushing it down. Holding it until it solidifies. Alright. Now that's sitting nice and flat. I also want to make sure that this little guy that's sticking out here that's connecting both of these together is not too close to the edge here, because if it touches the inside of that doghouse, it will short out and the fuse will blow. So I just want to make sure that's not too close to the edge of this board. Okay, now the cool thing is the next person in another 15-20 years, when they got to change caps, they'll be able to see what values I put in there. Yeah, they can look at a schematic, make sure, but it's just always nice, clean work if you show people what you did, because I wouldn't have known that these were 30 UF caps if they were all upside down. And don't always try to replace a component in an amp, you know, without looking at some kind of schematic or diagram if you want it to be original, you know, unless it was purposefully modded, because, you know, people don't always put the right values in. Now, in this case, I have a feeling the person that did this work, they did pretty good work with that master volume. It doesn't look sloppy. It looks fairly well done. So this was probably done on purpose with these 30 UF caps, I'm guessing. I don't know why they wanted to give it more capacitance, but he essentially doubled the entire bank of filter capacitors here with double 30 UF, the rating. And in a lot of these Princeton's, or sorry, not Princeton's, but in a lot of these old Fender amps, they used 22 UFs in a lot of them around this era. So 30 was even higher than that, right? 30s for everything. So, you know, I just don't. It definitely isn't. It wasn't stock anymore, and the amp probably had a little more stiffness, so to speak, due to that. You know, like as a player, you might feel that stiffness in the amp. Maybe that's what the guy wanted. You know, he's like, I can make this a little bit tighter for you, feeling. But this amp wasn't designed to be like that. It was designed with these lower 16 UF caps. And perhaps that's one of the things that gives it its character. So, alright, there's that one. And we just go right down the line. Except we also, I might as well start doing this now. These 10K resistors that I want to put in here. There's a couple of things that need to go. Give me 1 second. This one I think needs to be bent a little bit further down. Yeah, we got that, and we also got to squeeze in a fourth connection in this hole. But fret not. We'll make it work. That's the one nice thing about these eyelets, is that they definitely allow for quite a lot of components that can be connected in the same place, as opposed to some other methods where the holes aren't as wide to include as many components. Eyelets are old school, but hey, they work, man. They're clean. You don't have to wind up squeezing so much stuff into one space. They can definitely take even more than four, probably 4 leads in here. What I'm trying to do here is, actually, I'm gonna go ahead and solder the back one first, just to anchor this in place. I'm going to put a little solder on there, and then I'll see if I can push it down a little bit more than it is. Need a little bit more here. Try to hold it as still as you can so it doesn't move while it's solidifying, and then it should be pretty solid. Alright, 3 of them done. Just make sure these guys are solid. I think they are. Yep. The other nice thing about, I don't know if you noticed the way I'm doing this, is I'm giving just a tiny bit of space underneath this resistor instead of putting it flat on the board, just to get a little air under there. I mean, I know it's going to be in an enclosed doghouse, but they will get warm. These shouldn't get super hot, but they'll get warm, and they'll last a lot longer if they can have air on all sides. For anything that gets warm, I will say. That's why I'm trying to lift them up just a little bit. Since these are like the dropping resistors, it'll dissipate the heat more efficiently if air can move around all sides of it. Whoop, that's a little too much of a bend, sorry. Something like that. There we go. And, you know, these resistors are not polarized, so it doesn't matter which orientation they go. I'm going to make them both face the same way. That way anybody trying to read the values will be able to see the stripes in the same format. So I'm just going to put a little bit of solder here just to hold this in place. Maybe a little bit on this end, just to kind of hold it. Yeah, it has about maybe a quarter of an inch underneath of it that it's sitting up, and that's all it needs. It's just so it's not totally pushed against there. Now, if I did push it against there, it'd probably be fine. You know, it's just good practice if you know that this resistor is meant to dissipate heat. Or is going to dissipate heat, I mean, you know, give it some air. I'm trying to line these up as best I can. I know it might not be perfect. That's because I can't get my head totally under there to see just with the lighting and the cameras I have here on this. Is that about right? Yep. Alright, I'm going to go ahead and... is that too much? Oh, that looks good. I'm going to go ahead and just anchor this to the back first. Since I've got 3 components, well 4 actually, there's a wire, 2 resistors, and the cap. I'm gonna try to get this ready so I can push down on this a little bit. Oops. I'll recheck everything and see if there's any touch-ups that need to be done when I'm finished here. But yeah, these are looking really good so far. And then the last guy, the capacitors are not going to get hot, or at least they shouldn't. Unless you've got them installed wrong or there's another problem going on where they're going to explode. But yeah, they should not be dissipating heat, so they can go flat against the board. And I would recommend putting them flat against the board so that they're not bouncing around. You know, they're not jumbling around like this and wiggling around in transit. Definitely have those against the board, nice and secure. Just those little resistors there, it's good. Get a little extra air under them. All right, I'm gonna do the same thing here. I'm just gonna solidify the back. Basically try to push this down in there. And then let me see if I can. Okay. Just trying to straighten these leads a little bit. Yeah, they're all pressed up against there. Gonna touch up this back connection. This looks like it needs just a little bit more. Fill it in. Oops. I think these look pretty good, but yes, sir. Alright, we got brand new caps. Let's see if I can get you sort of a final angle here of the front of this. Now, I'm going to go ahead and not be a hypocrite talking about the leaving flux on those connections and actually clean off my connections. At least a little bit. I mean, most of this flux is the old stuff that's on there that I may or may not be able to get off, but some of it has like soaked into the cloth wire, I can tell. So no matter how much I try to clean these, I might not be able to get them perfect, but I'll at least get the majority of the nasty wasties off of there. Keep these from corroding. Ooh. Yeah. So you see how I gave these little resistors just a little bit of height? Just a tiny bit so that they're got some air being able to circulate around them. There it goes, hitting the camera again. Man, how many times does he hit this camera? 1,000? I'm gonna actually snip off this little. At this point, I can go ahead and put the screws back in. Okay, and bear with me 1 second. I'm going to clean off the negative terminals just a little bit. I mean, there's a little bit of flux from, and most of this is the old stuff. I mean, I didn't add any flux to these connections, but my solder has some flux in it, right? It's usually not enough to make it really dark and brown like this, so I'm mostly cleaning up the old residual stuff that used to be there. And I'm running out of Q-tips here, so I need to stock up here in a minute. Okay, last two. Okay. Alright, let's take a look at our work here. Ooh, there's some real crusties back here. Alright, it's better than it was. Okay. See all the crusty wusties here. Okay, we've still got a bunch more caps to replace on the inside board, but that's how we're looking. Pretty nice. Looks clean. Brand new caps, good quality, new resistors. We'll feel a lot safer that they'll be more reliable. And I just want to check continuity and make sure I get that same result. And what that's really going to test for is making sure that, remember, we tested it before, making sure that those little wires that connect some of these eyelets together underneath the board, that I didn't disturb those or move those. So that means these two should be connected. Good, they are. This one should not be connected to either of these two, right? These three should not be connected, right? Now, these are being connected through the resistors, and we can clearly see that they're there, so that's no big deal. And the other thing is making sure that all 5 of them are grounded. Yep. And that none of these here are grounded. See? They're all going to be positive end, and we're not getting any continuity to ground there, so that's good. Alright, so our continuity tests are good. Let's flip this guy over, see what's next. Alright, I'm back after a little break here. Now that we've got the caps done under the doghouse, I was trying to figure out what's a good way to film this and do the rest of this work here on the inside that needs to be done. And I was just thinking, we do want to put it back to original, so we're going to have to take this master volume stuff off and modify the bias. Why don't I just work from one end and just go down, and that way I can sort of check things as I go, and work my way down and put anything back to original that's not supposed to be, and just double check everything, check the values that are in there, because I haven't looked at every single component or tested every single component, but I can just sort of do that as I go along and try it that way. Most of the time people just would take things by sections, you know, like I'll just replace all of these brown caps here and then I'll move on to the next set of components. But I was thinking, it might make sense and be more thorough if I just work my way down the line and check things as I go. So that's the approach I'm going to take for now. I may change that after a little bit, but we'll see. I'm just going to check these real quick. So we have this is a 0.1 capacitor here. It's reading now this is in circuit, 0.15. That's okay, I guess. This is a 0.047. Yeah, see, that's the problem, is that it's probably going to be affected by these pots and stuff. Yeah, see, I think as I turn the pots, I'm going to take face value for these. Sometimes when these are in circuit, unless you lift one leg, you're not going to get a super accurate reading in circuit. But I'm just going to check at least some of these resistors that I know I can check in circuit, just to see if they've drifted. Oh yeah, that's cool. So this is a 100K resistor, very common value for this spot here in most Fender amps for the first gain stage. And that's actually lower than 100K, slightly, 97.8, 98. That's cool because sometimes they'll have drifted quite far. Wow, that one's also low. So, and that one too. Huh, let me see. What else do we got here? Is that 100K as well? Yeah. It might read higher out of circuit, 95. Usually when I'm looking at these things, they're around 110, 115 nowadays. These haven't drifted much. I wonder if this amp really got much use. It might not have, which is cool because... Oh, sorry, you can't see that there. I'll check all the I'm just checking the 100Ks right now just to see if there's any that are out of spec. No, see, look, they all are reading really low. That's strange. Okay, here's one that's 106. That's a little higher. But all these are within tolerance. I mean, you got to take these with a grain of salt because they all have probably at least 10% tolerance, which means they're going to be right out of the box, brand new in 1964 when they put these in there. They're going to be anywhere between 90 and 110. Their rating on here, the color band rating is 100K, but, you know, that's within 10% tolerance, right? So all of these are within 10%. Either way, you know, up or down. So, and they're pretty close actually to 100. So that's just checking a few resistors as I go. So, I mean, pretty cool. I'm just going to check and see. There's a, what is this? A 250 picofarad. Hold on, let's try. Yeah, see, it might be hard to see some of these in circuit. Yeah, I can't check that one. This one's a 0.047. Oh, shoot. This is not the right lead for this meter. I need to find the right lead. Yeah, 0.046, so that's good. This one's 0.1. Yep. 0.047. So that's 0.052. All looking good. 0.02, this guy. Yep. It was 0.18, right, or whatever, 0.018, which is very close to 0.02. What is that one? 500 pico. Hold on. These ones don't seem to want to be registering much in circuit. What the heck, man? Didn't have my scale right. Yeah, 0.48, so that's 500. This one's 250, so it should be around 0.2, 0.28. Why is this one? Oh, there we go. It wasn't registering before. Yeah, I got almost 0.4 on that one, and that's a 250. But that could also be because of it being in circuit. So as long as I'm getting capacitance on these guys, I'm fine with that. I'm just kind of hand checking a few of these for now. Yeah, I mean, everything's looking decent. Alright, I'm going to go ahead and start doing some of the work that we know we need to do. Hopefully my voice is coming through nice and clear. And sorry if it kind of gets loud and quiet. It shouldn't be too bad, because when I edit these videos, there's a filter that will adjust for low volume. It should add some compression to my voice for that. But when I step away from this microphone, this one here, it may no, the volume may change slightly. So apologize for that if that's happening. But I got a different view for you here. So this camera here, this little guy, is from behind the amp facing towards me. Right? I'm sitting right here working on the amp. So I thought, that's out of my way. I'm not as likely to knock it over unless I hit the cord or something. So maybe you can at least see the close-up view a little bit, and it's not in my way as much. So hopefully I won't knock it over. We'll see. Alright, let's get these old electrolytics out of here. At least let's try one, because I do have a slight concern about the size of these new caps. I mean, they are quite big. Look, here's... I mean, it's not the full length of the board, but it's pretty close. So, I think it'll fit across the board. It's just a matter of, will it fit between the components that are there. I really like this because one, it's a brand that I know and trust and like. It's definitely very good quality. They probably didn't need to make these so large, but I'm assuming they had to because it's two 25 UF caps, but it's only 25 volts, and usually the smaller voltage rated caps are a lot smaller. Like, you know, some of the caps that they made, these Astrons, that's what I'm replacing, usually the modern day equivalents are so much smaller. You know, like, I could put two really tiny guys in there and it's still the same value and does the same job. But I kind of wanted to keep this like Fender did it, so that's why I ordered these double can caps. Alright, so we're going to lift the leg out here. Sec. Sometimes when the stuff doesn't want to melt on you, you add a little extra solder. There we go. Alright, so we got both ends, positive side out, and oh, sorry if I hit that camera. It's still in my way, right? Hold on. Man, that one's a toughie. Oh, I know what that... I can't pull that out, that's why. This is tied... This is the lead for this Astron cap. They used this lead for this cap to solder to the brass plate. So literally this wire here that's going across, hold on, see that wire here, that's actually the negative lead of this can cap. So I'm literally going to have to snip that out and leave that lead there in order to change this. No big deal, but that means I just need to be careful to leave a little bit of extra. So let's see. Alright, so that's what the Astron cap looks like, the old one. And yes, this is, see, this is going across there, so I need to make sure I can cut that down just a little bit more than that, but I need to make sure that stays in there because this is a ground point for all of these components here, including the new cap that we're going to add. Alright, so, and the other thing I want to check here is we've got two resistors that are, I think, 1.5K. Let me just see if I can get a reading on those while I can get to them now. Make sure they haven't drifted too much. Okay, 1.8 and 1.8. They're in circuit, so they might actually be closer to 1.5. Hold on. I am inclined to just check one of these. The reason being, I'm going to take one of them out real quick and test it out of circuit. Just all you need to do to take it out of circuit is just lift one end. So I'm going to do this one. The reason is, even that little bit for where these things go, these are going to the cathode of these gain stages, and even a difference between 1.5K and 1.8K can make a change in the sound, the tone. It can really affect the tone. Mostly the gain characteristics. Well, they are 1.8. Now, technically that's probably not more than 10%, or is it? 1.5, 1.8. It's probably hitting its limit. So it's reading the same thing, even out of circuit. Question is, do I want to... I'm just going to leave it. I'm going to leave it. It's not that far out. If these had drifted up to like 2K, I probably would replace them because it will tonally make the amp sound different. But since, you know, I don't know if these have actually drifted or were they just always a little bit higher than 1.5. It's really not that much. I'm going to go ahead and leave them. Again, we're really going for originality here. Is it going to make that much difference on tone? Probably not that much. But it is good to see what they are, in case, you know. Alright. Hold on. Okay, here we go. So now what I'm going to do here is take the new component, bend the leads down, straight down, because these things are pretty long. Now I got to be careful with this because I did not order extras of these, I don't think. I only have 3 of them. So I'm going to make the leads a little longer than they need to be at the moment, because I can always cut them short, but I can't make them longer. Alright. So what I need to do is see if it will fit under these wires. That, I'm telling you, that is tight. Come on. This is quite a large cap. But I think it will work. I'm not forcing anything too hard. I'm just trying to be careful. Get this lead out. Okay, there we go. I mean, I think we have just enough. Yeah, I mean, it'll work. Alright, so what I need to do is I'm gonna go ahead and do the back side here real quick. Again, it was a little longer than it needed to be, so I can chop a little off. Just not too much. This is going to need to, once I solder it, it's going to need to get pushed back a little bit. I'm going to add a little fresh solder here. Okay, and then son of a gun. Push that down in there, let it solidify, and this needs to get pushed over. Alright, cool, yeah. I mean, I think lengthwise it's fine. It's more the height that's a little bit more concerning. Alright, I'm gonna go ahead and trim these guys just, well actually, I may not need to do that. You can't see really the front with the close-up view here, but I've got the two leads, the positive leads. I think what I'll do for this, just so that you don't have to watch the entire process of this, is for the other guys, as long as they'll fit, I'll go ahead and change those off camera and just show you when I'm done what I did. But this one you can just see like what the process is. If you have a Fender amp like this, and you want to use these caps, just be wary of that because they are quite large. A lot bigger than I thought they were going to be. I should have looked at the dimensions, but I was just looking at the description and I thought, oh, this is cool. This is kind of the modern day replacement for those Astrons, right? Just with a really nice high quality cap, but size wise I wasn't looking at the specs, and I figured here we go. So once I get the leads down in there, it gives it a little bit more room. Hold on. I'm going to cut off a little more of this one. It's just a little tricky because there's not much room to work with this. Alright, there we go. I can push that down. Alright, now we're not quite as tight on these now that everything's pushed down and soldered down in there. Alright, not bad, not bad. Just look at the back side here. Yeah, it's quite large. Here, I'm going to show you from this angle. Give me a second. I know you can see from above, but so yeah, I mean it's big. Sorry, it's definitely big, but it's heavy duty, good quality. These leads are really nice and strong, and actually be really easy to check the voltages here because you got so nice terminals to use if you need to. So yeah, I mean it's a good cap. Hopefully the rest will fit. I mean these were pretty big size to begin with. We only have two more that we have to do. So like I said, I'll probably do those off camera and then we'll come back to the rest of the stuff we need to do. But yeah, I mean this is on there good. It's not going anywhere. It's very secure. And I can still get to everything. The only thing I can't get to would be those resistors underneath. But you know, if we had to do something or change those, we just remove the cap and do it that way. I mean, the Astrons, it's very hard to get to these resistors even with the Astron caps in there, you know. I mean, you can sort of get to them, but they're almost pushed up underneath of there, so you'd have to remove those too, probably, to get and change those other resistors if needed. And there's not a lot of voltage going through there, so those resistors don't typically burn up or anything like that. So Alright, well, I'm going to do the same thing for these other two, and then I'll probably be back after that. Okay, ladies and gentlemen. I've done some work here off camera. Just want to show you what I did. So, you saw me replace this capacitor here, which is the dual cap for the 25 UF on both sides. And I replaced the other two. So, these are the quote-unquote fallen soldiers, the old Astron caps. Pretty cool, but they're electrolytic and their time is up. And I did notice that they are leaking. This one maybe not, possibly, but these two are. You could see some fluid coming out of there, so definitely past their life. There was another cap that I replaced as well here with a Sprague. This is just a single 25 microfarad at 25 volts, this Mallory. This guy's a 25 at 50 volts, so it can handle even a little more voltage if needed, but it fits good in that spot. These guys were a little bigger than I liked them to be, but they did fit just fine, and they're heavy duty, so I feel pretty good about that. The other thing that I did was I went down the entire board, and I pretty much hit, I think, almost every solder joint. What I wound up doing was kind of sucking up as much of the old solder as I could and just putting down some fresh solder. The reason is that a lot of them, there were semi-cracked and or maybe fully cracked solder connections on a lot of these. It's just the solder was so old and brittle over time that I noticed that you could see little spaces and little cracks if you got really, really close on a few of them where the leads had moved or, it just dried up and sort of started to crack. So even though the amp was working, everything seemed to be making contact, but this will just secure all those connections. So I went down the board. I also was testing a few more components. Most everything looks to be in spec. I'm going to test a couple more, retest a couple more, I guess, just to be sure. There were a couple that have drifted here and there, but not enough that really concerns me. I mean, most of them were within 10%. I also changed this cap right here. See this yellow cap? This is a Mallory .001. This is that one that I suspected might not have been stock, and I was right. So they had put this guy in. This green one, I was like, I've never seen a green one like this in an amp in one of these Fenders. So this is a .022 capacitor, and it looks like it's one going to the phase inverter. So I don't know if they were trying to adjust the phase inverter sound a little bit, but in either case, I wanted to put that back to stock because this whole amp's going back to stock, per customer request. So I had this Mallory. This will do the job for that spot, so that's back to spec now. The other thing I did was unmod this little section here for that master volume, and this is the fallen soldiers here. Basically, we have here, we'll get a closer look at this this pot, because like I said, I've never seen one of these before. It's a really cool pot. It's a dual gang pot. It has a pretty good long shaft on this thing. That's what she said. But yeah, I mean, look at this thing. It's got a little wheel, and there's like a little dot there that it kind of clicks against. Sorry. I don't know if you can hear that. I just put it up to the microphone. But yeah, it's a cool pot and everything, and I don't know what its value is. It doesn't say on here. This is a Japanese made pot. It says Alps, ALPS. Okay, hold on, here we go. 2N, 4N, 100K, AX2. 2N, 4N might be a part number, but I don't know. It looks like a 100K pot. Either that, or it does have one of these terminals on the back, so that might be a fourth one for some other reason. I don't know, but these are the three that are being used. I don't know. Very cool little pot, but this came out because we're not doing a master volume with this. And the other thing is that, remember I mentioned that this person who added this included these .22 UF caps as part of that.
And these are the two blue molded caps that were kind of moved in position. Like this one was moved over to this tube socket and then over to this terminal strip for the master volume, and this one was moved also. So it was going through the 0.1s and then through the 0.22s again, which was kind of weird. I just don't understand why they did that, unless they were specifically trying to change the overall tone of the amp somehow through this master volume. So in either case, we took that out. I put the two blue molded caps back, but now I'm thinking I might replace these. The reason being is that these are critical when it comes to the bias supply and part of the bias circuit. So if one of these fails, then your power tubes are going to go up like a puff of smoke. So we definitely don't want that to happen. And what I think I'm probably going to do is put these orange drops in there, because these are very, very reliable caps. Like, these hardly ever fail, and these blue molded caps are known for failing. Now, if this was in a position where it was like a tone cap down here near the preamp section, I definitely wouldn't replace it, if unless it was specifically bad, right? Or it was a noisy cap or something like that, which I haven't really banged on all these with it in circuit to see if any of them are sensitive to noise. Over time, some of these could become sensitive, and you tap on them and you hear a loud bang through your speakers, you'll know that you should probably replace that cap, even though it is technically working electrically. If it's a very noise sensitive part, you should probably replace it. I haven't done all that yet. I'll test those, but since these are tone caps, I'm going to leave all these in to keep the original mojo of the amp. But these two here don't have as much importance as far as tone goes compared to what they're doing to protect your power tubes, right? So I'm going to probably just take these out for now, just for reliability. I'm afraid that if we leave them in and one of these does happen to fail, I feel like these, it's a pretty common practice to replace these as far as if you're going to do anything with this bias board and replacing these parts, which I am going to do. So I should probably just put those in. Again, I wanted to keep this as original as possible, but we also want to make sure that this is reliable and safe. So it shouldn't mess with tone or anything like that. We're going to put the same values in there as was in there to begin with. These are 0.1 capacitors, but these I think are going to be a little bit more stable. They're brand new. They're very good, high quality stuff, and they're very unlikely to fail, whereas these are pretty likely to fail. I mean, they're 60 some years old, and they do have a tendency to fail more frequently than some other caps, right? We're going to leave all the tone caps in. I'm not changing those, just these two. All right, the other thing I did was I took this little bias board off. Now, I was trying to figure out what this person was trying to do here. So this whole board here was kind of clamped onto the screw for this screw here for where the transformer leg is, right? And the whole thing was connected by one wire right here back to the original bias board, which is this, right? With all the original components still on the original bias board. So this is almost like a recreation of a second bias board that's connected to the first. So I'm like, maybe if one of you guys know what this guy's trying to do, but my gut says maybe either something was failing on this board and he just said, oh, I'll just make this board and I'll tack it in, and then if the bias fails, this is like a backup bias board in a sense. But they're both in circuit at the same time. So I don't know. I'm assuming this is kind of what he was doing. I don't know. Let me know what you think. But we really only need one bias board, but I do want to replace and update the parts on this for reliability. One is this is an electrolytic cap, so this has to get changed. The diode, I measured it. It seems to be okay, but I know that a lot of times these diodes have failed in a lot of these Fender amps that I've looked at over time. So I do want to replace the diode, and there is a resistor back there that's a 1 watt. I'll probably replace that with something just a little bit more higher wattage, right? But yeah, other than that, there's the bias adjust pot here and this resistor. This is all original.
And all the wiring appears to be original here. It's just like they just added this extra bias, negative bias supply voltage to the board. You know, this was just added as an extra. I don't know if this is just like a backup. I mean, it's got a diode. It's got the cap, which is also a 220 UF cap, which I thought was pretty high value for this. And this is a, what is that, about a 39, hold on. Let me see if I can find out what that actual value of that resistor is. It's what is it, orange, 39 is white, red. Yeah, it looks like there's no other band on here, right, besides that and the two reds. So it says this is a 39.2K or 39K resistor, which looks like about a 3-watt metal oxide type resistor. And the one on the bias board is 470 ohm. So I don't know. And then there's another little component on here that looks like a diode, but I don't know what that is exactly. If you can see it, this little orange guy right here with the one stripe on it. Anyway, if anybody might know why this guy put this on there, please leave a comment if you could for me, because I've never seen this done like this before. Especially when all this stuff is still in circuit. Like, he didn't disconnect this bias board. If he's trying to make his own bias board for the negative voltage supply, why would he just connect it to this one too? So I don't know, maybe some kind of backup is my thought. But you know, and which is smart. I mean, if that works as a backup, great. You know, it's just a secondary safety thing. I'm just not sure if that was the intended purpose of it or not, because the values are different. So yeah, but I am going to get in here and service this. So let's see, I'm going to change these two here, these two caps here for bias. I'm going to update the components on this board. Probably going to leave everything the same here, and I did want to change a couple of resistors out of the power tube sockets and give them fresh ones and something with a little higher wattage rating as well. Actually, I didn't test those. Let me test those real quick. So I think these are supposed to be 470 ohm, and they put 1 watts in there, I believe, carbon comp resistors. Hold on. Yeah, so this has drifted a little bit. So this is 630 ohms now, that one. And this one is 0.45 ohms. So, or sorry, I mean 450. So this one's a little low. It's supposed to be 470 ohms. So this is 456 ohms, and this one was 630. So yeah, if these resistors are not equal, or at least close to equal, then you're going to have an unbalanced bias between these tubes, because this pot just adjusts the level for both tubes at the same time, the way this circuit works. We could add a component where we have a pot that raises or lowers the bias for both tubes, and then another pot which would do a balance between the two so that you can make them equal. That way you don't have to have a matched set of power tubes. What I might do, if you want to keep these original tubes, which are a different brand, so we have a Sylvania and we have an RCA. If we want to keep these tubes, and I replace these resistors with equal value 470Ks, at least very close, and as long as these resistors are close and the 1.5Ks are close and these are close, all that should be equal. We should get the same negative bias to the tubes. However, we know that power tubes are not all the same, right? So if these are way off and not balanced, and we want to keep these, I may add an adjustable bias where we can raise it up or down and use the existing pot to adjust the bias between the two to balance them. You see what I'm saying? It's kind of a dual way to adjust the bias. Raise or lower and balance it to make it equal between the two. That way both tubes are working the same amount. Not one's not working harder than the other. They have an equal push-pull. That's why people get matched pairs in their amp, right? Or a matched quad if it's 4 power tubes. And it's much better for the amp, and everything works more balanced than, sometimes if you have one tube working harder than the others, then that tube's going to tend to fail much quicker, right? So I'm going to do that. We'll have to test the bias, but I'm not going to update that. I'm going to keep the bias circuit the same, just update the components with some fresh stuff that's going to be more reliable. So yeah, let me get to that. I don't know, maybe I should time-lapse this for you so you don't have to sit through all of the soldering and me talking. And then I'll come back and explain what I've done. Yikes. I'm so stupid, guys. I thought I had hit record on my software. I swear I did. Maybe it stopped. Maybe I bumped it and it stopped recording. But I just did a bunch of work. I was going to time-lapse this for you. Sorry about that. Here's what I did. Changed those 2 blue molded caps to these 2 orange sprigs. So that way orange drops. That way they're more stable. Retested all these components again for their values, and they all look great. I completely rebuilt the bias board here for the negative voltage supply. So I changed the diode. I changed the 470 ohm resistor here to a metal oxide resistor that's 2 watt. I believe. I think they had a 1 watt in there, so a little better. And then I put this new F&T cap here for the bias supply. So this is going to ground. I spent a lot of time cleaning this because there was so much nasty flux. And also I noticed that a couple of the solder connections were it had almost like black fingernail polish on them. I've never seen that I can think of in a Fender amp like this. I don't know why just those ones were done like that, but I have no idea. Or maybe the guy that modded it did it, but it just was gooped all over the stuff in the back here. So anyway, this has all been totally cleaned, crust free. I cleaned the bottom of the board. I cleaned the little wafer board underneath that's keeping everything secure from, insulated from touching the chassis. I didn't do anything with this ground connection here, and this is where it's getting the negative bias off the chassis. So that's the same, and I've been really kind of yanking on that as I was flipping the board around here and there. So I know that's a pretty stable ground connection. I haven't been able to pull it off of there, so otherwise it's going to redo it if it looked like it was weak. But no, that's bonded really well on there. So Fender did a good job on that solder joint. Anyway, I'll get in here and clean some of this old flux up a little more in a bit. But yeah, so I've done all that off camera. I think what I'll do now is I want to do a couple of things with these power tube sockets, and this is really just for maintenance, reliability. Let me see if I can get the camera to actually stay here. Give me a second. It's going to be all over the place for just a minute here while I open the stand up. Here we go. Hopefully I can clip this on and you can kind of see the power tube sockets, hopefully. Problem is there's so many cords everywhere that it's really difficult to stabilize anything. Okay, you should hopefully be able to see the power tube sockets over here, at least a little bit. Okay, so what I'm gonna do, a couple things. I'm going to replace the 470 ohm resistors here that are just carbon comp with these really nice Vichy Dale wire wound. These are 6.5 watt resistors. These are high quality. I mean, these are probably 5 times the rating than what these are. These are probably 1 watts in here, but these resistors tend to take a lot of heat. So this is excellent quality to do the job. So I'm going to remove these guys and put these in. I'll put a couple of 1.5K resistors to replace the ones here on pin 5. And also, I might need to move this cord here because they're using pin 1, which is not being used, to go from to mount the 1.5K resistor. I think what I'm going to do is run the wire here and put the 1.5K resistor just tacked on to pin 5, and then join pins 1 and 8 together with a 1 ohm shunt, which I'm going to use these high quality ones here that I just got recently, to ground. Right now pin 8 is being grounded, but I'm going to go through pin 8 to pin 1 to ground. That way we can monitor the bias through the tube itself, and it'll be a much more accurate read than trying to use some kind of a bias measuring tool. It's I think the best way to do it. There's already a connection to ground here. I just need to make sure that these solder connections on the chassis are good, but I really just need to put this resistor in through that. I may actually take those off. They look a little crusty. But anyway, a little bit of work to do on this side of the chassis now. I just want to sure up these power tube sockets, and while I'm at it, I may hit the other pins with some fresh solder. You know, suck up some of that old solder and put some fresh stuff on there and just make sure that everything's solid there. Super important, good to do for maintenance, and yeah, just little stuff like that. So I'm gonna focus on that. Now that we've got the bias supply done and the pot and everything I didn't touch, that looks good. The adjust pot, everything there looks fine. You know, we redid the board components relating to that side of things. This looks good. This bias board definitely needed to be rebuilt. I mean, there's a lot of crusty wusties on some. This is the old diode. These old types of diodes I find in a lot of amps of this era have failed over time. So maybe this one was failing, and maybe that's why the guy built the other board. Why he wouldn't just change these, I don't know. Or maybe, you know, he had a backup board, like I said, and he just popped that on there in case this negative supply fails. But now that we've got all brand new stuff and everything's been cleaned up, I don't see a need to have some kind of a backup board. So yeah, we took that out. And as I go here, I'm just going to clean up some of the old flux in little spots that I see. I've been kind of cleaning the board as I go. I'm going to go back over a lot of this stuff and try to get as much of the old flux up as I can. Again, it is corrosive. It's not going to be that corrosive to an eyelet board like it would a circuit board, but one thing that could happen is as it gets crusty and it crystallizes, it can cause solder connections to crack over time. And two, it can become conductive, right? Over time, like old flux that's brown and crusty, if there's enough of it between two solder joints, it can actually start conducting between the two joints if, you know, it bridges across. I don't really, in this amp, they're pretty far apart, but there's a couple little spots that look like, you know, there's always a potential for it to get. I've already cleaned a lot of that. Like, there's a few spots that are really close together. I can see where it's just crusty, and it's almost like that layer of crust is touching between two solder joints. If I clean that all out in there, we will never have to worry about that getting conductive and causing some kind of a short. So just like to keep things clean. It's important. It does matter. It doesn't just make it look nice, but it'll make the amp more reliable and function well. So all right, let's get to the next part, and I guess if I remember to hit record this time, I'll do a time lapse. All right, summary. We've got the power tube sockets all in good shape. So here's what we did, and I know if you, just in case you skipped the time lapse part, we have the 470 ohm resistors now replaced. So these are really nice 6.5 watt Dale resistors, and we have a 1 ohm shunt now from pins 1 to 8 to ground, and I just used the existing ground spot for that. That way we can measure the bias accurately through the tubes themselves. And I moved these 2 wires here for the negative voltage going to pin 5 from the bias supply over here, and just moved it, instead of going through pin 1 to pin 5, I just moved it over here to go straight to pin 5. So, and I replaced the resistors too, just because, you know, we definitely want to make sure that they're good quality and operating. So I just put these little metal film ones on there. Again, that's really just for the negative voltage. So heat shrunk, all nice and secure. Put a couple zip ties on the heater wires over here so this doesn't move as much. I may go down the line if there's room to bring these together and do the same thing with some of these, but it's how I like to do my heater wires a lot of times. If I'm going to float them up above the tube sockets like this, and just put a zip tie between the 2 sets, and it keeps this really nice and stable, and it also kind of keeps it, you know, not so spread apart, so you can work on stuff. So yeah, I'm gonna, let's see what's next. I haven't cleaned the pots yet, and the tube sockets looked really good. Like they look like they might not even need to be cleaned, but I'm still gonna take a look at them. Maybe at least clean the power tube sockets, the octal sockets here, because they're big and open. But all these preamp sockets look really nice and shiny. I'll take a look at those again, and I'll just see if any of these need to be retensioned or if there's any broken. I doubt there's even going to be any broken pins, but we'll see if there are. And yeah, let's see. Clean the pots and just kind of do the rest of the cleaning on here, and then I think we'll be ready to fire this up on a Variac and kind of take a look at it, giving it slow voltage, you know, a little bit of voltage at a time, test some things and see where we're at. And once we get up to full voltage, if everything looks good, we'll retest everything, and then I'll kind of come through here and we'll do some chopsticking to tap on components to see if there's anything sensitive. We'll see if any of this work has changed the vibrato feature, because remember, it didn't kick on until between like 5 and 6 on the intensity. So I don't know if this roach clip needs to be replaced or not. I mean, these values of these resistors and stuff in the circuitry here don't appear to have drifted too much, but you know, it is possible that if they drift enough, it could throw off that range of intensity. So it could be that too, but we'll take a look at deeper stuff like that so we can get this thing operating just as it would have been when it came off the factory floor, right? But yeah, I mean, we're looking good now. I think it's looking a lot better. I think it's a lot safer than it was. We've got some really good, nice, high quality, reliable components, yet most of the stuff that is going to deal with the tone and everything like that is all still original, right? So we've really just beefed up all the electrolytics and the bias supply, power tube stuff. All right, let's move on. Alright, if you guys watched any of that time lapse from the last section, probably pretty boring, but cleaned all the tube sockets. I retensioned the tube sockets just for the power tubes. They did look a little bit wide, but I was very, very careful and delicate just to try to give each pin a little extra tension to grip the tube pins. Let's see, what else did I do? Lots of various cleaning inside. I tried to clean all of the board's tube sockets. There's a lot of like flux around there. It's hard because a lot of that flux has now seeped into the board, the eyelet board itself, because it's kind of like a very hard compressed paper. So it's really hard to get it completely out of there, but I just wanted to try to get as much of it off as I could. I know it was very tedious going through there with Q-tips and just doing every single individual solder joint, but it is a lot cleaner now. It does look a lot nicer now. You'll see a lot of shine around there, but that's the old flux that's seeping through the paper. So it's like no matter how much I clean, there's still going to be some of that look to it. I wish I could get it to look brand new, but the only way to do that would be to replace the board. So at this point, we want to keep that original. I just was trying to clean as much junk up as I could. Cleaned all the pots, compressed air through them, and also deoxit to clean all those. I cleaned the bias pot. I cleaned up this whole wire for the heaters and put zip ties around each joint here. So this is very secure. It doesn't move now at all. It feels like an iron rod is going through this thing. It's really nice and secure. So I don't have to worry about that bending and moving and twisting. And it's also easier to get to these pins if we need to solder or unsolder everything. These pins all look fine on these. I mean, aside from a little bit of flux, the solder joints on those all look good. So, we just did a lot of work on the power tubes. The rectifier tube socket looks fine. So I think we're ready to go with the amp as far as everything being serviced. And then we'll have to test to see, are there any other components we need to replace because of noise issues or anything else. So I put this aside. I wanted to test these tubes. So let's start with the 5AR4 rectifier. So this is my, I have a couple of different tube testers. This one really I just rely on to give me a basic status, to make sure the tube's not shorted, that it's working. We know that all these tubes should be working because I was playing the amp earlier. Hold on a second, is that filament on? Yeah, I just have this in an angle you won't be able to see if the filament's glowing, but I just need to make sure it's heating up. So as it's heating up, this will just give me a general overall health. Oh, look, it says short. This is lit up short. That's strange, because why would that say short? Okay. Do I have some? Maybe I have something set wrong here for this one. Give me a second. I know this can't be shorted out. It was working. All right, let's see. There's two halves of this, so the other half would be, so what do I have? 4 and 8, 4 and 6. Oh, I know why. Duh. I had the pin up the wrong direction. 8 needs to be down. All right, I knew something was going on here. All right, now it's heating up good. So 5AR4 is the same tube code as GZ34, and when you buy a modern today you'll see GZ34, but the old school, and according to this tube tester from way back in the day, the indication was 5AR4, so it's the same exact tube. Yeah, so looks good there. Let's put 6 down because that's the other side. Yeah, so I'm getting like almost a 9 out of 10 rating on that. Totally good. This probably isn't perfectly calibrated, so as long as I'm getting a strong reading, I'm happy with that. All right, so let's move on to the 6L6s. All right, so the shunt's 18. Sorry, I'm gonna move my microphone here. It's hard to tell if I'm exactly on 18 or not, but let's see. Line is 3, so we go 1, 2, 3. Obviously 6.3 for the filament. 3, 4, and 5 up. 2 and 8 down. All right. Let's go ahead and pop this one. So this is the Sylvania. All right, let's get a general overall health on these. Okay, I can see the filament heating up. Let's just give it a few seconds here to get warm. My guess is probably most of these are going to be pretty good. Now, I know power tubes are always, you know, luck of the draw here to see if they're good or not. You know, the fact that these are two different ones makes me think that maybe something happened to... I don't think Fender would have put two totally different brands in, but who knows if they did or not. Maybe one of them, one tube went bad and, you know, they replaced it with another one. Alright, so yeah, I'm getting like a 8 out of 10 on the health scale. Again, this is just a general indication. I wouldn't really worry about it unless it's getting way down into the weak range here. But also, if my shunt isn't quite at 18, it might read a little higher. So yeah, that's almost a 9 out of 10. Alright, so we'll just say for now, this one's 9 out of 10. And if it gets a little, if I let it get a little hotter, it may actually climb a little bit on the health scale. Okay, so here's the RCA. I'm going to leave everything as it is, and we'll see how this one compares to that one as far as strength goes. Really, this is just more of a strength thing and a life indicator for me. There's other things you can test with tubes, different emissions tests and all these other things. It's not going to test for microphonics and things like that. If the tubes are anywhere between, I'll say, like 8 and 10, I think we should leave them in the amp. And then as we turn the amp on and we get everything fired back up, if I bang on them and they're really noisy, then yeah, we might have to replace them because they're microphonic. But otherwise, yeah, this one's right around the same level. So these tubes may be close to 10 out of 10 if I let them warm up just a little bit more. And, you know, if my calibration is off. Because look, if I just turn this just a teeny bit, it goes up to 10. So I don't know if my calibration is perfect here. I calibrated this thing like a year or two ago, I think was the last time I did, so it could be slightly off because of line voltage, things like that. So overall, those power tubes look good. I don't have any complaints there. Now, that doesn't mean that these are a matched pair, even if their health indicators are around the same point. They could still, one could be like 20 milliamps and one could be 35 milliamps. We just don't know until we go in there and start testing the bias. So, you know, take that with a grain of salt. This is just, should I leave them in my amp or not at this point in time? Yes, probably. And then we'll test it. If they're way off, then we may wind up having to put a matched pair in there. We'll see. All right, so let's get everything reset for 12AX7s. So for these, we have to test both sides of them. All right, so shunt is 11, 6.3. Selectors on 1 and 2 up, 3, 4, 5 down, and we're using the 9-pin socket here. So we got to test it one side, one triode, and the other side, because each tube has a triode, which is essentially in this amp a gain stage, right? So 7025, if you're not sure. Oh, this is an AT7 right here. Sorry. This is an AT7, so something's going to be a little different on this one. It's almost the same tube, but you do have to change something. Let's see, 12AY7, 12HT7. You have to put the shunt on 24. Alright, so that would have shown really weak. Alright, hang on. Alright. Alright, the shunt on 24, but everything else should be the same. 1 and 2, 3, 4, and 5. Oh, the selector on 2. Huh, that's strange. Wonder why. Huh. Alright, well, let's see. pegging the meter. This might be a little high. Alright, well that's pegging the meter on that one. 12 AT7. 6 and 7 are up. 4, 5, and 8 are down. Okay. Should still be pretty warm. Yep, pegging the meter on that one. Alright, so let me just make sure that shunt is correct. It says 24, yeah. 20. Yeah, that's 24 right there. Oops. Sorry about that. Yeah, I mean, it's, if it goes past 10, it should be very good. All right, so since that's a 12 AT7, that's a General Electric. I had that one here. There's another 12 AT7 in here at this point, and this is probably for, ooh, these are really crusty. Yeah, I'm gonna need to clean these two pins. If these tubes are good, these are extremely crusty. I don't know if you can see that, but if they're not shiny metal, they're not gonna make a very good contact in the amp. Let me just see if I can brush a little bit of that off. I may even need to take a little tiny bit of steel wool to these if they're really crusty. Yeah, that's a tiny bit better. But anyway, let's test that since we have our settings the same. Alright, and the rest of these should be 12 AX7s. So, or 7025. Now, as I was saying, 7025 is just a slightly less noise prone 12 AX7. It means that someone's gone through and kind of checked for noise levels on a much different testing type of device to see which tubes were made have the lowest amounts of noise, and then they essentially label them as 7025s. But the internal parts are pretty much the same. So yeah, this one's pegging the meter as well. All right, let's see, what else did we have? Oh yeah, 1, 2, 3, 4, and 5. That part of it is the same as a 12X7. The only difference here is the line adjust and the shunt value. Yeah, I mean, both of these look 100%. These two 12AX7s. All right, so let's do the first 7025, which again is a 12AX7. Yeah, these pins, like the pins are like a blue color because they've oxidized so much. So hopefully these are good enough. This could be another reason why, if the amp was a little scratchy and stuff, even dirty pins can make a difference. All right, so for 12 AX7s, we need to put the line back down to 1. Selector down to 1, and then everything else is the same except for the shunt is now 11. All right, let's get this warmed up. So far, both 12 AT7s, both power tubes, and the rectifier tube are all looking excellent as far as, you know, power and life left in these tubes. All right. Got about an 8 out of 10. I don't know if my shunt is exactly on 11. Hold on. I think that's closer to 11. Yeah, like 8 or 9 out of 10. Again, this, I don't know if this is calibrated perfect, but 6 and 7, 4, 5, and 8. Yeah, between 8 and 9 out of 10, like an 8.5 roughly. Still pretty good. Again, unless it's microphonic, probably just use it. RCA tubes, I'm telling you, RCA tubes, I think personally, the new old stock, these guys were excellent quality, excellent sounding tubes. So even if you have one that's a notch weaker than like a brand new, you know, Electro Harmonics or a Russian tube or whatever, these are probably in a vintage amp going to sound better in general, even if it's a little weaker than a brand new tube. I just think these RCAs, they just have this warmth to them that feels, you know, the breakup just feels so natural and vintage. All right, so that's like close to almost a 9 out of 10 on that triode. Then 1, 2, 3, 4, and 5. Same thing, maybe just a little under, maybe like an 8.5 out of 10. Still good health. And then 2 more to go. Here's a 12AX7. This is an RCA. Again, I think I need to clean all these tube pins. They are all very dirty looking, and or have like a film on them, you know, like a corrosion film, like a patina, so to speak. Okay, we got about a 9 out of 10. See, the fact that these are like 9 out of 10 might also indicate that this is a little off. These might actually be like a 10 out of 10 for these. Yeah, 8.5-ish to 9 out of 10. Okay, and what I'll do here is on... Oh, wait, that might have been the last one, was it? No, here's the last one. This is a 7025, another RCA. That's interesting. So maybe one of these was replaced or something at some point, because there's this one is labeled 12AX7A. This one's 7025. This was probably in V1. V2 was a 12AX7. V3 is a 12AT7, which would have been for the either the tremolo or the reverb driver or both. And then 7025, then 7025, and then another 12AT7 for the phase inverter, I'm guessing. Yeah. And then onto the power tubes. And I kept these in the same order as the amp. So yeah. So yeah, one of these is a 12AX7, which is not really a low noise, but it still could be low noise, you know, even though it's a 12AX7. There's not that much of a difference between 7025 and 12AX7. So again, another like 8 point, nope, that's a 9.0 it looks like. So 9 out of 10, 1, 2, 3, 4, 5. That other triode, 9 out of 10. So here's what I'm going to do. I'm going to grab a tube that should be new. And if this one reads 9 out of 10, then I'm thinking that all these are actually 10 out of 10. So here's a brand new JJ ECC83S. It's the same thing. It's a 12AX7. Let me see what this one reads. I'm pretty sure this is new. If it's not, I'll grab another one. But if it reads about 9 out of 10, then I think this is just calibration, and almost all these are 10 out of 10. As far as strength goes. Yeah, see, look. 9 out of 10. Let's check the other triode. 6 and 7, 4, 5, and 8. 9 out of 10. So none of these 12AX7s are 10 out of 10. The 12AT7s were, but we were on a different line adjust. So I think this selector one might need some calibration. There could be a resistor that's drifted slightly, because almost all the amps I've been testing 12AX7s lately have been around that 9 out of 10. So I just wanted to check it with a new modern tube to see is there any difference. Yeah, maybe it's around 9.1 out of 10. Again, not a big deal. Let me just pop one more. One more of these back in there just to see. I bet if I let it sit there for an extra minute, it probably would read a little higher too. They really got to warm up good to get an accurate reading. Yeah, I mean, look, that's not almost 9.1 out of 10 right there. So 6, 7, 4, 5, 8. And again, not all triodes are equal, so this one is a little bit under 9. It's like an... Oh, no, wait. Hold on. Nope, 9.1. So I'm betting, based on that the strength of almost every single tube in this amp is a 10 out of 10. If I put them on a different meter, I bet you. But either way, as long as I was saying, my general rule of thumb, if I get it between an 8 out of 10, I think, and they're vintage tubes, most of these are originals. Maybe one or two of them aren't. But they're still old. Like this 12AX7 is still an old RCA, new old stock kind of a tube. It's not a brand new modern tube. Both of these power tubes, even though they're different, are still very old tubes. 1960s, I'm guessing. Maybe 50s even, late 50s. And this old General Electric one as well, around the same era. This might be the original. This RCA may be the original. Maybe this one was replaced. You know, maybe one burnt out or got smashed or whatever happened. But yeah, looking good on tubes, so I'm happy with that. I'm gonna see if I can clean these pins. I'll probably do that off camera, so you don't have to watch all that stupid work. But I'm gonna see if alcohol will just kind of take the little dust and little, you know, film off of there. And if not, worst case scenario, you can kind of take like a scraper, like this is a plastic scraper, maybe even a metal, almost like a screwdriver, like a flathead. And if it's really stuff caked on there, you can kind of carefully, very carefully, don't apply a lot of pressure, but you can just almost scrape the gunk off of them. But yeah, I'll see if alcohol will get these clean. And maybe even just a cotton ball with some alcohol will do the trick. But yeah, they definitely are not all shiny anymore, except for the ones that I just scraped. I just scraped that one. It's pretty shiny now. But you want that to be shiny. You want metal on metal. We want 100% contact of metal on metal and not a film in between there. And that will guarantee success. Or at least better chances of success than not. And here's our bag of fallen soldiers. There's quite a lot of parts, but most all these are caps. A couple of those resistors and the parts that guy for the master volume that we took out, and the extra bias circuit or whatever that's not needed. Yeah, but yeah, a couple of resistors here and there, a broken fuse holder. So, all in all, not bad. And then here's the doghouse with all the extra parts. I'm going to clean all these guys up too. See if I can get them polished nice. And we'll see what we can do about this. These are rusty, but it is possible to clean this rust off, and I have a couple different ways I can do that. It might not look 100%, but it might look better than it is. So once I get to that part, cleaning the cab, cleaning the hardware, and things like that, I don't know how much of that I'll film, but I'll probably at least do some time-lapse stuff of that, so you can kind of see how I get all that cleaned up. But the goal that I have of this is to try to make this amp look as new as possible with what's there, right? Like, it would look better if I replaced the grill cloth, probably, but then it's not going to be original grill cloth. It won't have the exact same shades and all that. I know this grill cloth is shaded, it's got some holes in it, but I'm going to try to clean it best I can to at least brighten it up, so that when you look at this amp, you're going to say, oh, is that a 1960s? Man, does that look clean. Right? That's what we want people to see. It's not a reissue. It's the real deal. It's old school, and it's been well loved and well taken care of. That's what I like to try to do on these restorations. So, on to the next part. Hope you're enjoying so far. All right, cue the Rocky theme music. Here we go. We're going to start this amp up for the first time since it's been serviced. We did a lot of work to this thing. All the tubes are reinstalled. I've got all the tube sockets cleaned. What else did we do recently? I did clean the tube pins off camera, so all those pins are nice and clean. All the tube sockets are retention, so the tubes are nice and tight in there. I checked all the connections over again just to be sure against the schematic that everything is all original, at least, you know, value-wise. So this is back to its original stock state with a couple of new, well, pretty good handful of new components with these new electrolytic caps and all the caps under the doghouse. I've actually got the doghouse closed because we can test everything we need to up here where the wires from the doghouse come out to check high voltages coming out of the capacitors up there. I've got, let's see, here's my setup. I've got the variac over here. We'll be able to monitor the voltage from the wall going into the amp, except the only thing is with this digital meter that I added to this, and if you ever want to know how to do this, This is just an analog variac, and here's the problem with these analog variacs. If you've never bought one of these or used one of these, but you're thinking about getting one, here's something to keep in mind. I've done this to several of these. Almost every single one of these things is not accurate on the top here. So this is not turned on right now, but as you turn this dial up, these voltages over here on the top are not accurate. This particular one is off by about 15 volts, meaning when I put a little blue piece of tape here, I don't know if you can see it, but this is at the 105 volt mark. So when this little arrow gets to 105, that's actually 120. So that's how far off this scale is here, this little peelable scale. So trust me, it is not worth relying on this, because if I had gone up to 120, I really would be trying to feed it almost 135, 140 volts, which would blow something up for sure. So don't rely on that. And if you're not sure and you don't have a digital meter, use one of your multimeters set on AC, and you can touch like the fuse here, for example, to see how many volts of AC is actually going into this amp. Don't rely on this meter up here. And these are good units. I mean, this red one here, you'll see these standard across like Amazon and stuff like that, eBay, and things. Just make sure that you're not overdoing it, right? Don't go past, if you're in the US, don't go past like 120, 125. Because that's what our wall voltages are. However, if you want to add this digital meter to it so you can see exactly what's going through it, I do have a video on my channel that'll say how to add a digital meter to your variac, right? To your analog variac. So it's very easy. It's like 4 wires, something like that. And I show step by step how to add this. Now the only issue with this is this screen won't light up until we get up to like, I don't know, maybe 30 or 40 volts, maybe even close to 50 volts, something like that, because it needs enough power to power this thing. So once it gets up to that point, you'll see this screen start to flicker, and then it'll come on. In the meantime, I'm just going to use the scale that's down here because it's fairly accurate at the low voltage settings. Once you get up past 50, then this scale starts to be out of whack. So by the point the screen comes on, we'll know. You'll be able to see it here. And the other nice thing about the digital meter is not only is it showing you how many volts is going in, but there's a little indicator for the current, right? How many amps is this whole unit drawing? How many, actual amps of current is it drawing? And that's a good thing too, because we have a 2 amp slow blow fuse in this amp, and if we get this thing up to like 50 volts, which isn't even half the voltage it needs, half the voltage would be 60, but let's just say we're at 50 and we see it drawing almost 2 amps of current, we know that something's wrong. There's a short going on somewhere. So we could shut this off, find our short, come back to it. Otherwise it's going to blow this fuse, or at least we hope it would blow this fuse if we got too much current being drawn. And that would be something like there's a short. There could be a short in a tube. There could be a wire that we did wrong, something like that. So we definitely want to keep an eye on how much current the amp is drawing as we bring this up slowly. And this is a safe way to do it so that you don't shock your amp all at once. And the other good reason for this is, I don't know how much of this is actually true or not, but a lot of people say that with brand new electrolytic caps, it's better to bring them up slowly and let them start to form inside instead of shocking them with 400 volts all at once. Because this transformer is going to bring the wall voltage of 120 up to like 400 for the B+, in that range, maybe even more than 400. So if you just turn them on right away, they say that's not good for the caps the very first time. It's better if you slowly bring it up. And that way we can monitor things while we're bringing it up at a safe level and be able to shut it off completely if something's wrong, right? If we see something that doesn't look right. So that's the whole point of using a variac. The other thing I have here, you'll see this big light bulb back here. It looks like it's lit up, but it's not. That's just the lighting in the room here. I'll keep an eye on this, and if this looks like it's starting to glow really bright right away, then we have a problem. We have a dead short in the amp. So this will take the power away from the amp and keep the amp safe if that happens. So the variac's plugged into the wall. the light bulb limiter is plugged into the variac, and then the amp, the guitar amp, is plugged into the light bulb limiter, right? So it's kind of a chain. So if there's a major problem, this is going to take the heat, and I'm going to say, hey, wait a minute, why is that glowing so bright? Now, it might glow a little bit once we start to get up past like 60 to 120 volts, in that range. If it's very faint, that's fine. You know, if I start to see the filament glowing, it's supposed to draw a little bit of current. But you don't want this thing to be super bright right out of the gate. And that's the whole point of using one of these. I don't always use one of these, but since we did so much work, that's what I'm going to do. All right, so let's go ahead and get started. I've got 2 meters here. This one here, the red one, I'm going to keep on DC volts. And of course, it's going to beep at me because I've had it on for too long. So if you hear that beep, that just means, hey, reminder, you've got this thing sitting on. Right now you can see it says 108.1. That looks like, you know, DC volts, but it's actually millivolts. So the reading up here says MV for millivolts. There's a little bit of voltage in those caps, like a minute amount, just a tiny, almost like static electricity. So that's what this is showing. It's not showing 106 volts. It's millivolts. That's less than a volt. It's like 0.1 of a volt. So that's normal to see right off the bat, even though these caps have never been used before. And I've got it monitoring it. Actually, I have it monitoring it at a point where it's going to go past the rectifier. So the AC from the wall is going to turn into DC with the rectifier tube. Now it's going to take quite a bit of voltage, maybe 30-40 volts at least, before we start seeing any DC voltage here, because the rectifier has to heat up enough to start rectifying, to start changing the AC over to DC. The other thing is it's going to start filling up the caps under the doghouse, right, for the B plus voltage and all that, right, which we could monitor B plus voltage right here on this spot right here, because that's where the red wire of the output transformer is, which is the primary, the output transformer, and this black wire is a choke. So at this point or this point, we should get the highest voltage in the amp right here, right? But I'm going to monitor it over here on pin 3 of one of the power tubes, which means it's going to go a little further than just this B plus part. It's going to go all the way through the output transformer, and then this one's beeping at me too. It's going to go through the output transformer, convert over, and you'll see the high voltage over here on the primary of the output transformer. So that's where I'm going to monitor the high voltage, is at pin 3 of one of the power tubes. It doesn't matter where I do it, but if I start to see this start to climb once we get enough voltage going, then I know rectifier's doing its job, the the filter caps are doing their job, and the output transformer is doing its job, right? So that's kind of an assurance that I've got everything all the way to the power tubes working, getting DC high voltage. Okay, so yeah, let's get started. And then this one I'm going to poke around with, you know, and just check other things. The main thing I want to check is, because I redid all this bias stuff, there's a possibility now I missed something. I missed a wire. Remember, I unmodded it for that extra bias board that guy had. You know, I could have missed something, right? So if I don't see negative voltage up here or at pin 5 of the tubes, once I start bringing this thing up, then we know something's wrong. We need to figure it out, shut the amp off, and then troubleshoot it right at that point. So we have enough to get started and be safe, I think, at this point. Oh, you know what? Let me see if I can change this battery real quick on this meter. Let me turn this one off, just because I see it's showing a low battery. I haven't changed the battery on this one in a long time. Let me just see. I just want to make sure I've got all full stuff ready to go. I don't remember how this... Oh, easy as that. Okay. So it takes 2... I don't think I've ever changed the batteries. These batteries lasted a long time. I've had this meter probably a couple of years, and I use it all the time, so that's pretty cool. Alright. Alright, I've got some nice high-quality Duracells. Brand new. Just want to start fresh here with Good battery. Make sure we're getting good ratings. Good readings, I mean. Alright, let's go. I've got the knobs of the amp under here just to prop this up so that you can see the screen a little better. This is an illuminated screen, so if actually the higher it is, the better you can see it. Hopefully this will be good enough. See that 0.001 DC volts? Hopefully you can see that. Alright, let's get this one on. Let's get this one on. Alright, here we go. Oh, and also you want to make sure the amp is on and the standby switch is on. Now I've already set the volume of the amp up a little bit, maybe on like 3 or 4. I don't have the knobs on, so I don't know exactly. I tried to set the treble and the bass roughly around half. I got the reverb turned down and the vibrato controls turned down. Both of the switches turned up. I'm plugged into this channel for right now. I do have a guitar hooked up, and the volume on the guitar is all the way up. That way I can just kind of reach over here and hit the strings to hear if we're getting any sound. And I also have this plugged in to my computer through the Captor X, 2Notes Captor X box. So the audio of this, once it comes up enough voltage for you to hear it, will be coming directly onto the video for you, so you can hear it as well. So that reminds me, I do need to plug in a pair of headphones so that I can be ready. Otherwise, I mean, I could have it come out of speakers, but then you would be hearing my voice echo because my voice would also be coming out of the speakers like that. So that's why I need headphones. All right. I don't know. It might sound cool. It might sound like I'm in a spaceship while I'm working, right? All right, here we go. Headphones are ready. So I don't need to grab those just yet. Can't forget, got to get a sip of iced coffee. Oh, good stuff. Okay, Variac is on. We're ready to go. We have no voltage going in. What I'm going to do is change this meter to AC. I'm going to put it on the fuse right here. And as I turn this dial slightly, you should start to see AC volts over here, right? Wait a second. Let me make sure I got this. 12 volts of AC. Yeah, sorry, I don't think these were pushed in all the way. What is going on with this? There's something wrong with this one test lead, I think. Of course. Let me try something real quick. Let me see if I can replace this one. I got to go through all my test leads because I have 1 or 2 that are not working right. Hold on, let's try this one. Just needs to be in there nice and tight here. Okay, 12 volts. You see that? So I've basically turned the dial. You can't see the dial up here. Sorry. I've been you'll see my hand reach here. So I've been turning the dial here to 12 volts. And I have to make sure that this is right on. So I'm going to go to 15 volts. Okay, so we know 15 volts of AC are coming in to the amp. We've got no DC volts over here. This is just millivolts, 63 millivolts. One thing I can check at this point, though, because we're doing a diode for the negative voltage, is do we have any negative voltage here at all? DC voltage. And we do. Look, even at 15 volts, I've got negative 5.8 volts on this resistor and negative 5.8 on that. That means we're getting negative voltage for the power tubes. So if I go over to pin 5, we should see the same thing. Negative 5.8 on that one. Pin 5 on this one. Negative 5.8. That's great. That means we have negative voltage for bias. If we didn't have negative voltage there, or, you know, that's actually quite a lot of voltage. What I may wind up doing is... it doesn't matter right now. Hold on a second. Let me get a screwdriver. So keep an eye on this meter. See negative 5.8 Hopefully you can see that. I'm going to go over to the bias trim pot and turn it this way to turn it down a little bit, because I'm only at 15 volts. Well, here's all the way down. Actually, the more negative it goes, I guess it doesn't really matter. We'll leave it where it is right now. I didn't leave it where it was before I did the work, because I did actually have to clean that pot. I cleaned the bias pot, so we know that we're getting negative bias. That's great. I'm gonna go up a little bit more on this. Let's switch this back to AC real quick and check. Here's another thing we can check. Let me go up to about 30 volts of AC. 29. I'm just trying it doesn't have to be exact. Here's 30 volts. Okay, so 30 volts of AC is coming in from the wall. That's the fuse. So here's what we know. We know that the voltage is coming in through the fuse. This is the wall end of the fuse right here, and here's the other end of the fuse. That means the fuse is good and voltage is going through the fuse. Good stuff. The other thing is it should be going into the power transformer, because if we check, what is it, the red wire here, we now have 85 volts of AC on the rectifier tube. And look at this. See this? This is already starting to climb. That's millivolts. Now it's volts. It just changed to volts. So now it is. This is the one that's on pin 3 of the power tube. We have 1.5-ish volts, and it's continuing to climb. And that's going to continue to climb because now the rectifier tube is starting to get just a little warm, right? But I also am checking the the rectifier tube voltage. Why is this so high at 85 volts? That's because the transformer is doing its job. It's transforming that voltage to a higher value, right, for the rectifier tube. So if I come over here to the pin with the red wire coming out of the transformer, we got 85 on that side, we got 85 on that side, because remember there's two sides to the rectifier tube. The yellow wires are AC wires for the filament, right? So the filament should be 5 volts total. However, it's going to be very low right now because we've only got 30 volts coming in. So we have like, let me see if I can get a steady. It's so hard for me to get. There's so many things going on here. I should be seeing a little bit of AC voltage here. Hold on. 50 volts of DC. Why are we getting DC voltage? Hold on. Oh, is that the pin that's changing it over to DC? 60 volts of DC. Okay, maybe that's rectifying. Oh yeah, here's the voltage. Here's the total voltage. Sorry, I was getting confused with my meters and what's set up for what. So yeah, this is all going to the power tube. So the rectifier is doing its job. It's rectifying the AC to DC. So here's 75 volts of DC. So far so good. Now let's check a couple of other things. Let's check. I just hope that this meter is working correctly because of these test leads. Okay, I'm gonna come all the way down here to one of these new caps, and probably not enough voltage to actually show anything right now because these are on the cathodes, but we can check these 100K resistors, and yeah, we have 85 volts, 86 volts of DC down here for the first tube. If I go to pin 1, hold on. Pin 1, we should get high voltage of, 90 volts almost now. So that means high voltage is getting all the way down here to the board, to the components that need the high voltage. So that's the plate of V1, right? The other one is we could check V2. We could say plate 1 of V2, 90 volts. Pin 1 of V3, 90 volts. V4, same thing. Now these could vary slightly, and the voltages are going to be a little bit different depending on the tube and what its job is, but yeah, 93 volts. And as we get up higher voltages, we'll be able to tell. Okay, so we have 95 volts on the, let me do one thing. So this is 96 volts of DC on pin 3 of that power tube. Let's see if we can check pin 3 of the other power tube, and it should be around the same amount, just to make sure that. The only problem here is that it's really hard to get to pin 3 because of the fuse holder and some other stuff. I don't know if I'm going to be able to get this probe. I might be able to temporarily get it down in here. See, 100 volts now. So yeah, I don't want to leave that there because it's just risky that I might short something out. So I'll leave it on this one. Well, pin 3 over here, there's a little bit more room. Just as long as I know I'm getting that 100 volts on both of them. Okay, so far so good. Let's give it another 10 volts total. And see if we can get this screen to start to come on so you can see it. Here we go. Just a sec. Here we go. Now we can see exactly. Let's go up to 50 volts total. And just let it sit there for a little bit. Alright, now you can see the digital screen. Here's what this is telling us. 51 volts are coming in from the wall to fire up the amp. Current being drawn is 0.2 of an amp. Okay, so that just means that if you think about, we have a 2 amp slow blow fuse in the amplifier, right? That means this amp shouldn't draw more than 2 amps of current when it's full power, and if it does, this fuse is going to be there to protect it, right? Like if there's a short, it might start to draw more current, and bam, the fuse will blow, stop the power from going in, protect all your components, right? The good news is we're only at 0.2, right? So that's like very, very small percentage of what this thing. Now we're only at 50 volts, but we're almost at half voltage. If we get up to 60, which I'll go ahead and do just for now, we'll just slowly bring this up to around 60 volts. Now we're at half the voltage required to operate this amplifier, right? At full voltage, 120 would be full, so we're at half. So only at half, we're only drawing 0.265. So the good news is I don't think there's any dead shorts. The light bulb's not lighting up at all right now. And at half the voltage, if we double this 0.2, that would only be around 0.4 or 0.5, which would be a half of an amp. So that's perfect. The 2 amp fuse would be there to protect it. If we were already at 60 volts and we're getting close to 2 amps, I'd be worried that something's wrong, right? So let me grab my headphones and guitar and just see if 60 volts and 200 volts of DC is enough to get audio out of this thing. I bet it's getting close. So let's see. Absolutely. Okay, cool. The good thing is we've got audio, so we must have done something right. Doesn't mean that we still haven't made a mistake. I still might find something as we bring this thing up. But all signs are looking good at this point. Like, I'm not seeing anything that looks wrong, that is a worry at this point. Like I said, we're going to keep a very close eye and bring this up slowly, form these caps the way they're supposed to be formed very slowly. Now, the amp's not going to sound great with 60 volts. It's going to sound a little not as powerful, maybe a little scratchy at times, but at least I know that I'm getting audio and it's working. So I'm going to bring this up to maybe 70 volts now, and just keep on going, 10 volts or so at a time, 10 or 20 volts at a time, and just very slowly let it sit there and check things out. 0.3 current, that looks good. Light bulb still not lighting up anything. 240 volts on the plates. Okay, I want to check something. I want to see what our negative voltage is now. Negative 24. Can you see that? Sorry, my lead's in a way. So negative 25 volts on that power tube, negative 25 on that one. That's good that it's even like that. And if we double it, it's around 50. So that might be a little high for this amp, meaning the bias is going to be a little lower than expected. But we can also start to look at the milliamps being drawn from the tube based on these little 1 ohm shunt resistors now. So multimeters on DC. If I go here, let me turn this off and on again, because these are going to start to beep at me. All right. So if I come over here to pins 1 and 8, oops, I should see. Now this scale is a little off, but it says 0.005, so that's about 5 milliamps, I believe, of current. Yeah, 4 to 5 milliamps of current going through. Now this one's at 9, it looks like. So this one's a little more than this one, and again, that's going to be a difference in the tubes, it looks like, but because these are probably not matched tubes. Well, we have plenty of room to get it up further. I wish I could change the scale on this. There's probably another way for me to do it. Let me see what live voltage will show. No, that doesn't do anything. Well, yeah, this one's this one's basically 9 milliamps. And this one's around 5. So one's working a little harder than the other, it looks like. We're going to keep going, but nothing looking out of place at this point. I'm going to switch channels just to check the other channel. Come on. Give it another 10 volts. Go up to 80. Just let it breathe a minute. Yeah, sounding pretty good. It's going to sound even better, you know, the more voltage we give it. More power, more stability. But I do want to test... I want to test some tubes here for microphonics and see if we see anything that appears to be overly sensitive. Hold on. Wiggling them a little bit. Huh, nothing. I mean, you can hear me tapping on the glass, but I'm not hearing anything come through the circuit, the speakers. See, I'm wiggling these preamp tubes pretty good, and I'm not getting any, you know, and nothing like that. That means that the tube sockets are nice and clean, the pins are clean, everything's tensioned correctly. All right, let's go to the powered tubes. No, just glass noise. Yep, wiggle, wiggle. Nothing going. Yeah. This amp just needed a good old TLC servicing, cleaning. I think all these tubes are great. Hold on a sec. Where are we at? 80 volts. Oops. Negative 27. Negative 27. That's good. Let's go up to 90. Okay, right around there. 0.42 of an amp. That's good. Okay, so far so good. Gonna go ahead and keep going a little more, give it about 100. Okay, now what I want to check now Okay, we're still good. We're still even under 0.5, a half of an amp. Remember, our max is 2 amps. Even this, the light bulb, it's a little warm, but it's not, I don't even see the filament glowing, so this isn't drawing any excess current. This light bulb limiter, I don't even see the filament glowing, so that's great. Like I said, even if it was glowing a little bit, that's fine, that's normal. We're up to 312 volts now for our B plus on the plates of the power tubes. Let me check with this meter again and see if I can get a reading of a bias reading of these power tubes. It's kind of weird again because the scale of this one, I may have to get a different meter. I wish I could set that. There's probably a way to do it, to set it a couple of decimal places over so it looks normal. No, that's on it. Selector's just going to change it between AC and DC. Alright, well anyway, let's just try this again. Alright, so here. Okay, now we're at 18. So 18 milliamps, basically, for that tube. And 17 for that one. That's good. That looks pretty balanced. What I'm looking for is probably, I'll have to check a bias calculator, but based on what this voltage is going to be, we'll do a little calculation for 6L6GC tubes and make sure that this is right. This is probably going to wind up coming out around 24, 25, and if we need to adjust it, we'll adjust it with that pot. But yeah, we got to wait until this gets up to full voltage before we can truly check that. But everything is looking like it's in range of goodness right now. Happy about that. Cool. I don't know what I'm playing. I'm just funking around here. And these strings, oh, I feel like I just changed them, but I use this guitar for a lot of different stuff, so they're already oxidized to hell. So it would sound a lot better if I had some nice brand new strings, which I may wind up changing before this video is done. Alright, I'm going to go up another 10. So we're almost at the full voltage. 0.5 of an amp, that's fine, that's totally normal. 338 volts. We're letting these caps form, new caps form very slowly, which is good. And there's no general rule of thumb that you got to sit there for 5 or 10 minutes between each set of volts or whatever. I mean, it's just don't shock them all at once, right? I'm doing this slowly over like a 20 to 30 minute period, you know. So, okay, this cap we've got 1.1 volts of DC, and then remember these are on the cathode, so it's going to definitely be low voltage. 1 volt there, 6 volts on that one. 1 volt here. Oops, where are we at? Oh, there's nothing on that one. Interesting. Where does that go? Is that going to pin 1? No, pin 3, sorry. That's interesting. Alright, I'll have to check and see what the voltage is supposed to be there. Is that for the reverb driver? No. All right, yeah, I'm gonna get in here and really check things. Let me just see if the vibrato works any differently or better or worse, or doesn't work at all. I do need to shunt this to ground, and again, I'm gonna build a little thing here so we don't have to use the foot pedal for this, but essentially what I can do is just short this out. So I just have a little alligator clip, and I need to touch the inside and the outside to ground out the inner side, and that should turn it on. Let's see. Whoa. Hold on a minute. Okay, something's not working here. Oh, duh. I'm on the wrong channel. I can't see the front of the amp, so I would have noticed that. Alright, start over. Which one's which? Here we go. I hear a scratchiness going on. That could be my input level on... My input level might be a little too high on this software. I need to check that real quick. Or it could be something going on with a part in the amp. We have to troubleshoot, maybe. Hold on. Where's input? Yeah, it's definitely clipping on the input. Nope, not that. Honestly, I don't remember where to set that. I'm going to have to look at my software and see if that's a problem with the amp or with the software. I think it's the software because I can see a little meter, and it looks like it's pegging in the red when I hit those certain notes really loud. So I don't think that scratchiness is the amp, but it could be. Let me just check something real quick. Yeah. So it's still behaving the way it did before servicing, and I kind of expected that. I didn't think filter caps would really do anything with that. What it's doing that I don't like is it takes about the pot to get almost halfway, if not further than halfway, before it starts working. So it has to get to like 5 or 6 before it even kicks in, before you even hear it. I feel like that shouldn't be like that. I mean, maybe that's how it is on these. I don't know. I've never even used one of these. They're pretty rare amps. But most Fender amps, usually, at least by 2 or 3, you would start to hear the effect. The other thing I noticed is that with the speed control, with it all the way down, it starts pretty fast. Now, I know that's always a gripe that I've always had with these Fender tremolos, is that they start too fast. And you can change one value and make it start slower, but still make it go just as fast, you know. which I'll ask my friend if he wants me to maybe make that change, because I really think that this starts fast. The other thing is, as I turn it, there's a spot around 2 or 3 on the dial where it just jumps to a really fast setting. Now, and then once I get up to like 6 or so, it just starts to get to the point where you can't even hear it. It's going so fast. So I feel like it needs to be slowed down and smoothed out, and something here with this intensity. What I might try to do is I might try to clip in or solder in the replacement roach clip I have to see if that makes any difference. I don't think that will. I think really a lot of that is going to depend on these disc caps here. These disc caps tend to kind of go bad over time. And again, I haven't chopsticked around in this thing yet to see if anything's sensitive. Let me just do that a sec. Hold on. Actually, let's get it up to full voltage. So let's go to 120. There we go. 21. Yep. 120, drawing 0.57 of an amp. The light bulb was... Yeah. I keep hearing my voice echo through those headphones. The light bulb, I can see the filament just barely starting to glow, and that's fine, especially at full voltage. So that's good. We don't have any shorts. 360 looks like what we're coming out on. So at this point, I know you can't see it, but I'm going to talk you through what I'm doing. I'm just going to the Ted Weber bias calculator online just to check real quick what the value should be. Sorry about that. Hold on. Here, I'll just keep that one off for now. So we have an AB, class AB, push-pull, 2-power tube with 6L6 GCs, plate voltage 360, and the bias should be around, it says 58.3 milliamps. That seems a little high. Maybe that's because these are the GCs. Yeah, hold on. If 58.3, if I switch it from 6L6 GC tubes to just 6L6 tubes, then the milliamp dissipation at 70% should be 36. So yeah, because it's 6L6 GCs, they can go a lot higher. So it says 58 for 70% dissipation. Now, I don't think this is going to be anywhere near that. Maybe that's why the guy added all that extra bias crap to this amp. Yeah, I've got 25. That's about half of what these tubes could really pull. 24. Yeah, and I bet you that hang on a minute. Let me see if I can find my plastic tools. I don't want to shock anything. Or this is wood, so that's fine. Yeah, because if you look at... Hold on a second. If we look at... Alright, so keep an eye on this meter here. Hold on. I got to change my screen here. If we look at this, 24 milliamp, and I change this to... Wait, that's going the other direction. Yeah, this is all the way up. This is the bias all the way up. 25 is as high as it'll go. Otherwise, as low as it will go is around like 9. And see, the voltage got climbed up to 400 there. Where did that thing go? Sorry, I can't see it. Here it is. Yeah, so yeah, so 9 is the lowest, 25-ish is the hottest. So I might need to adjust something. The resistor right here might help, or in order to allow this range to be a little bit more. And it could also be that, you know, the voltage is now, well, maybe that's the way Fender made it. Maybe they didn't want you to be able to put the bias up much higher, or it's just the way these tubes are. These particular tubes might be very low, and I stick a new set of tubes in there, and they might already be around 50. I mean, I've seen that happen before. So, All right. Well, I'll keep that in mind. I'm gonna move on from this, but definitely the bias is basically it's safe. It's ultra safe. It's kind of too low. I think we can get some better performance out of the amp, some more power out of these power tubes, because right now they're at about half of what they probably should be set at, as far as standards go. So it'd be like dimming your lights to about half power, which is as far as what this amp could put out. And maybe if we give it more power, maybe the vibrato feature may actually work a little bit differently. I've seen that happen too, because the vibrato feature does work off of the bias circuitry, right? It's making the amp bias the tubes very fast up and down, right? That's how you get that effect. It works with the bias circuit. So that might actually change if I get the bias on the tubes a little bit hotter. And maybe that's what that guy was trying to do with that other bias circuit. Maybe he was trying to make the bias go a little hotter. And I don't know, I'm almost curious to put that bias circuit in there to see see what it does to the bias. I mean, because all it was just tacking it in this extra board. All the components were all set up already, configured on the board itself. I could clip it in, maybe. But I'd want to clip it in. If I did that, I'd want to clip it in with the Variac at a very low voltage and watch what happens, because I've changed some things too, and I don't want to mess anything up, my work that I've already spent all this time doing, and have something be hooked up wrong and some other guy's mod screw up my work. I don't think that would happen, but I would like to see what the heck was he trying to do there. And maybe that little extra bias board was actually giving him the ability to set and change the bias to a much higher level somehow. It looks like it would be overkill if that was the case, because all you'd really need to do is change this one resistor here, not build an entire board with all this extra stuff on it. But yeah, I don't know. I might play with that and see what happens. Now that we're at full voltage, let me just mess with this a little bit more, and then we'll move on. Yeah, I can't play this unless I can adjust my input voltage on this Captor X thing. I think it's just clipping too much. Okay, hold on. Let me do one more thing. Let me try something. I'm gonna see if anything else is sensitive. Actually, I'm gonna turn my microphone off so you don't hear me tapping. And if we actually hear something through the headphones or through your audio, then we'll know that something's sensitive. Now, keep in mind that there are certain areas that are gonna make a little noise, like down here at V1. That's gonna make a little noise, but at least you won't hear it coming through my mic. So hang on, I'm gonna mute my mic right now. Okay. I don't know if you heard, but when I got to this little disc cap right here, that's the only one I heard that was a little sensitive. Now, like I said, you're going to hear a little bit down here at V1. That's the most sensitive tube. And tapping on those pins over here definitely will make a little bit of sound, but that was very small. This isn't super concerning, but I worry that over time this one's going to get worse. These little disc caps can become very microphonic. So this one might be worth changing. This is a .01 cap, and it goes to pin 1 of V2. Right, so that's actually high voltage there. But yeah, banging on that, I could hear it for sure. All right, well, I'm going to take a break now. I think we had a successful startup, at least. Everything is looking great. I think the main thing right now is figuring out, maybe trying to figure out what was that guy doing with that bias. Because maybe was he trying to raise it? Because it definitely seems like stock at this point with these particular tubes that are in it, it's too low. I mean, it's not too low to operate, but I think we could squeeze a lot more power out of this thing, a lot more wattage, if we were able to bring the bias up further. So maybe if I clip in his board and see if that changes the bias value itself, maybe that's what he was trying to do. Just did it in a way that I've never seen done before. Maybe that wasn't what he was trying to do. Maybe the bias will be the same or worse, but I'd like to see. I think it would be worth checking, and if not, then I can still adjust a value or two of a resistor so that we have a little bit better of a range that we can set it hotter or lower. Right now, we can't go past half. We need to get this thing up to like around 50 for 70% dissipation, and that would give us good tube life, but very natural, good, powerful sounding amp for the types of tubes that are in this. So all right, well, let's go ahead and switch off. You see our voltage going down. Let's see if that goes down to a safe range. It probably will because the standby switch is turned on. Yeah, it's already safe. Under 20 volts. That's not going to shock you. So that's pretty cool. Yeah, so there's a bleed resistor in there somewhere that's bleeding this stuff down to ground. Yeah, it's almost 5 volts, less than a 9-volt battery. So yeah, totally safe to work on. Now that doesn't mean that there isn't some other cap holding value in there, but the fact that this is on pin 3, it should be going through that whole entire network of capacitors. Like here's the main B plus, 5 volts. Here's another point right here, 6 volts. Yeah, this is where the choke is. 6 volts. This power tube should have around 6 volts. Yep, this one 6 volts. So yeah, that's pretty much the entire amp. So that's safe to work on. Now it's still not unplugged and it's hooked up to a Variac, so I still wouldn't work on it yet, but unplugging it, yes. All right, so we'll come back. I think this was great first startup. Okay guys, I am back. It's been overnight. My band had a show last night. We had a really good time. It was a local show here in Baltimore with some really cool bands, and that was a lot of fun. It gave me a break from work and amp stuff, but it also gave me time to think about this amp and kind of what's next, right? So there's really just two things right now that I'd like to focus on. One is, why is the bias so low? Why does it seem so low? And the other thing I realized is I looked at the schematic and notice that the voltage coming off of the GZ34 rectifier tube on the schematic says 410 volts plus 410 right here before it gets to, you know, where it connects to the first two filter caps, the 16 UF caps. So interestingly, I was getting 360, I think, somewhere around there. We're going to recheck it again. I'm going to recheck it again without the Variac connected and the light bulb limiter, because, you know, you've got other things in circuit that could throw it off. But that could possibly mean that this GZ34 tube that's in there could be weak, even though it was testing okay. It might not be outputting as much as it should. So that could be somewhat related to the problem. And if that's not it,
we'll just dive deeper into the bias circuitry. So I want to take some readings, and I also want to swap that tube out and see if the voltage changes. So let me just recheck everything here with bias. The other thing I wanted to focus on after sort of working out the bias stuff is the tremolo being a little weak and stuff. And I've got some thoughts on how to troubleshoot that. One is I want to recheck some of these components in that circuit to make sure they haven't drifted. I did sort of spot check a lot of the stuff, but maybe I was looking at a resistor and didn't see its value was 2.2 versus 1.2, and it may have actually drifted. So that could be, possibly why that it seems kind of weak. So there could be other reasons too. The driver tube that is connected to that circuit, maybe it just needs a stronger tube to handle that effect. So let's start with the bias, and also this B plus voltage. I'm concerned that it's lower than it is reading, so maybe we can figure that out. All right, multimeters are connected. One thing I'll do, well, actually, let's go ahead and get it started up. So it's completely disconnected from the variac. The volumes are down, both volumes, so we shouldn't hear anything. And I just want to work with the circuit as is. So I'll let it heat up a second here. Make sure all the tubes are all still in place. And this is with the original set of tubes. I haven't changed any tubes yet. I just want to get a couple more readings and make sure I'm getting the same thing here with wall voltage as I was getting with the variac. All right, standby. Okay. All right, so I have my multimeter here. I'm going to check what I think is the highest point in the amp. Oh, okay, we got 420 over here. Okay, good. Where was I getting 360? Oh, that must have been the plate of the power tube. Hang on a second. Let's check that again. Okay, hold on. Oh, Borscht 17. Okay, why was it so low yesterday? I don't know. Interesting. Maybe it had something to do with the light bulb limiter being plugged in. But hey, we're up to, and I would expect the B plus to be a little bit more now. Hold on. I would expect it to be a little more now than the schematic, because back in 1964, the wall voltages were around. Actually, let me do this. Let me power it down a second. I want to plug it in without the light bulb limiter and just plug the amp into the variac. That way I can actually set it to 1964 wall voltage averages, which would have been around 110. That'd be the rough average. They're not all exact or anything like that, but so let's go ahead and turn the amp on, and let me do this real quick. Alright, so you see the variac digital screen here. Wait a minute, is that plugged in? No, I unplugged it. 1 second. Sounds like we might be getting a thunderstorm coming soon, so I don't know if I want to do this right now if it really starts cracking hard around here. Alright, so let's bring this up. And we can see exactly what we're giving the amp. Let's go ahead and give the amp 110, which would have been the average 1964 wall voltages when this thing was made. Alright, there we are, 110. And let's let this heat up again for a second. Recheck that B plus. Let's see if it's around 410. If it is, okay, 391, yeah. So maybe it was 115 was the average. Let's see. I mean, it's somewhere in this ballpark, somewhere between 110 and 120. It definitely wasn't 120. Yeah, 405, 406. So you see that? So right here, this is where the red wire, where this is connected, and there's another black wire. The black wire is for the choke, and the red wire is the primary of the output transformer. So that's 406 volts, right?
I'm going to go ahead and turn this off. And I'm going to unplug the rectifier. Just curious if I'm going to get a different reading. So just doing a little experimentation. I've got a really nice tongue sole, made in Russia, 5AR4, which is the same thing as a GZ34. And where's the keyway? Keyway's like this. Okay, that's installed. Let's give this a second to warm up. I'm just curious, are we going to get around the same voltage or close to it with a different tube, or is it going to be a little different? Okay, it's starting to come up. Okay, 400. We just got to let things settle out, because as the power tubes heat up, they're going to be drawing some current. Yeah, 402. I mean, it's within like 3 volts of the GE one that was in there. So, yeah, about the same reading. Okay, so maybe yesterday something had to do with the way this was connected through the light bulb limiter and everything, because I was getting 360, which would have made the bias seemed very, very high to me. Not the bias reading I was getting, but the bias that it says it should be getting. Because at 360 volts, it was saying it should have been around like 50 some milliamps, and I know that's way too high for this amp. It should probably be somewhere around the 35 to 45 range for each of the tubes. So let's just check. Well, I should put the original tube back in, because we're definitely going to use the original tube, as long as now I've kind of proven at least that the tube is doing something, it is working just as well as a brand new tongue sole right out of the box that's never been used before. At least we've proven that. So let me get the original tube back in there. Okay, original tube. Let's get it fired back up, and then I'm going to check the bias now, because I have a feeling the bias is going to be a lot higher now, because we've got the correct B plus voltage. Okay, we should settle out somewhere around 405, and that's with 115, right? 114. All right, so let's get it up to current day wall voltages, 120. All right. We get somewhere around 424 volts. It's probably going to come down just a little bit as it warms up and starts drawing current. 0.7 of an amp current drawn for the entire amp. That's good. All right, let's take a look at the pin 3 of one of the power tubes, and we've got 421-ish. Okay, see that? Alright, so let's see what Ted Weber bias calculator says. Give me a second. I'm just going to go over to my computer here. And actually, I can show you this. I should be able to show you this. Hold on. Okay, you see my screen, computer screen? So I'm just going over to the Ted Weber bias calculator. We've got an AB circuit. We've got 6L6 GC power tubes. Plate is 420. I'm just watching it right now on the meter. Okay, it says 50 milliamps. That's still probably too high for this amp. It's only like a 35 watt amp, so let's just look at it with regular 6L6. Yeah, see, if this is regular 6L6 power tubes, more like 31, probably 35. The 6L6 GCs can handle a lot more, but as far as this amp goes, I'd like to get it between, I don't know, around the 35 to 40 range, and I think that would probably be really good. good sounding. Maybe like 65% dissipation. See, this would be at 70%, right? 606 GCs, which are in it, says 50, but I think that's a little too much. I think maybe around like 35 to 40 would probably be good. But let's see what it is now. Hold on, I just got to switch you guys over here. Okay, here we go. So let me take this off. Okay, and we should be able to monitor the milliamps through the 1 ohm resistor. Oh, good. And we've got 38.4 millivolts. Okay, so 38.3. So that's perfect. That's actually right in the range that I was hoping for at this voltage. And this one's 34. So this one's a little bit lower, but not that much lower. Okay, 34.1, 38.2. Hold on. Where's my... I wanted to write this down on a little post-it note, but I don't know where my post-it notes are. So let's see. Let's just recheck that real quick. All right. 38.2. 34.1. 38.2. 34.1. Alright, so I just want to write that down because I'm going to go ahead and switch it off now. Just because they're not perfectly balanced, but I mean they're within 4 milliamps, which to me is pretty acceptable. If we're not getting any crazy noise going on, because what happens is if these power tubes are, if one's drawing a lot more than the other current wise, then it could create an unbalanced circuit, which not only does one tube work a lot harder than the other tube, but then they can kind of become out of phase with each other, and you might hear a 60 cycle hum coming through the amp because they're not balanced well. To be perfectly balanced, everybody thinks, that's a great thing, but sometimes slightly unbalanced can actually, some people say that actually brings out some of the harmonics in the amp. So the fact that these are like 4 off from each other, hey, that's pretty cool. I don't think they're worth throwing out just because they're 4 milliamps off. Now, if they were more like 6 to 10 milliamps off, I'd be a little more concerned. But what I'm going to do now is I'm going to switch them, and I'm going to see if their milliamps follow the tubes. If they do, then that means that's just the way these tubes are. If it doesn't, then that means that possibly like one resistor, it might be in the circuit why they're unbalanced, right? So let's just take a look and see. It also could be a combination of the two. Their tubes are still very, very hot, so I'm trying to carefully take them out here. All right, so we had the RCA on the right and the Sylvania on the left. Oof. Man, that tube is super hot, but I'm also having to hold the little alligator shark teeth clips here. Come on, there we go. Oh man, is that hot. All right. All right, let's get this guy. Let's get this guy installed over here. Just checking it where the keyway is. Okay, Sylvania is on the right. RCA is on the left. Okay, Flip this bad boy back on. Just let things warm up here. I'll recheck this voltage. It's gonna take a second. It'll probably come down as the tubes start heating up and settle out somewhere around 420-ish. 423. Still got 120 on the dial here. Yeah. 120 on the dial. Yeah, 421. Okay. Alright, so that's our plate voltage. Let's see what it is now. So the left side we got 33.0. The right side looks like about, why is that drifting downward? Let me see if I can get this to stick on here. 39.1. Okay, so it looks like it did follow the tubes. So this is the original configuration. Oh, sorry. Turn the brightness down here. Right, so we had 38.2 in the original configuration and 34.1 milliamps on millivolts. Sorry, on the tubes. We switched them, so now this tube is this tube, and that's 33. That's very close to 34, and this is 38.2, and then it went to 39.1. So it's actually better to put these tubes in the original configuration because there's more of a spread. There's a 6.1 milliamp spread doing it this way versus doing it this way. And I don't really think that that's enough of a gap. I mean, it's bordering what I'm comfortable with. I'd say 5 milliamps for me for a balanced set would probably be any more than that. I'd probably not want to use that set of tubes or do something to change it, right? There are things you could do to use the same tubes and change it. We could upgrade the bias circuit itself to make it not only raise or lower the bias, but also balance the bias between the two. But that's going to require some mods to the original bias circuitry in order to do that. So I think what I'll do is, let's go ahead and shut this off. I think we'll go with what we have for now. And I'm going to do some testing with the amp and also take a listen to the tremolo now that I know that we've got full voltage on the amp. We've got the 420 volts of B plus and not 360 like I was getting yesterday. I think it was the way I must have had the light bulb limiter hooked up and it was drawing current from the light bulb itself, giving the amp less power. Because even though this light bulb wasn't lighting up, the filament was still getting hot. So it was keeping the amp safe if there was a short, but there was no short. So it didn't really need to be there in circuit at the time. It was just a safety thing to bring the amp up the first time slowly with the new capacitors. So I'm glad I used it just in case there was a problem, because that would have taken a lot of strain off the amp if there was a dead short. But in this case it wasn't, and it was kind of throwing off my bias readings. So it's always better to get a good bias reading just by plugging straight in. And I'm going to bias this based off of the Variac because my wall voltage may be slightly higher than 120 or slightly lower than 120, and it changes throughout the day. It might be 119 in the morning and it might be 123 in the evening. It could be, and even though it doesn't sound like a lot, that can make that 420 go down to like 390 if it's 3 or 4 volts lower. See what I mean? Because it's multiplied by what the transformer is doing to transform those volts to make them higher. So I'm doing it based off of a steady 120 voltage from the Variac, so it doesn't
waver too much, you know. All right, so we're back. Okay, I'm recording this on my phone because I feel like this is going to do a better job capturing the audio, since I'm not going to use the Captor X 2 notes anymore for demos with this amp, since it's only 4 ohms. But I wanted you to hear this. This little Ampeg cabinet here, it's one of those, I actually picked this up really cheap at like a flea market. It's a little bass, 210 bass cabinet, bass speaker cabinet. It was designed for bass. I took the speakers out of that years ago, and I put two 10-inch Raging Cajun speakers in here, which is going to be, I think, the same speakers as my friend's going to use inside this cabinet here. So it'll be very similar. The only difference is the shape of this cabinet and everything. It may sound slightly different. But I wanted you guys just to hear what this amp sounds like now, after it's been serviced and with this new Mercury Magnetics transformer, and it's just so glorious. It's just unbelievable. So listen to this range of frequencies. So the volume's pretty much on like 1.5 right now. Get it on like 2 for you, okay? And you may hear a little bit of hum. Right now I don't hear anything. There's no 60 cycle hum or anything coming through the speakers. But when I go like this, you'll hear, because my guitar is so close to these these transformers here, that it's going to pick up that electromagnetic field unless I sit a couple feet away from it, because it's not enclosed in a cabinet or anything. So just keep that in mind. This amp is dead quiet. I mean, I can't even tell it's on right now. It sounds like it's on standby, but when I turn my guitar volume up, you're going to hear a little bit of hum, and that's just my pickups being close to proximity to the transformers. So, okay, treble down all the way, bass down all the way. Even just right there at those settings with treble and bass down all the way, to me, to my ears, and the bright switch down, it sounds like a normal amp where everything's just set at noon, set on 5. Alright, so check this out. Listen to how bright this can get. Treble up a little. More. And all the way. Okay, I'm going to turn that back all the way down now, treble. Let's turn the bass up. Bass all the way up. I mean, this sounds like I'm playing through like a bass guitar, like through a huge 8x10 like Ampeg bass cabinet. That's how deep this bass is. Turn the treble up a little. Does not need to be that high. Matter of fact, in most instances, I would say for me, the treble and bass don't need to be past like 2 or 3. I know I don't have the knobs on here, but I'm guessing about where they are. Right there is just the most glorious tone. This bright switch, some reverb. I find it, for me, the right amount of treble for just clean sound, at least with this guitar. Turn the treble all the way down, but put the bright switch on, and that, to me, gives me just enough treble that I feel like it's not overpowering, but it's very crystal clear. Now, this is the original reverb tank that I'm playing with now. Sounds so good. I'm gonna turn the reverb tank all the way up and kind of move back here a little bit so it's not as loud on my pickups. The other channel for a second. Let's see. Let's come over here. Bring you over here a little bit so you can see the controls. I know. Oh, well, you're not going to tell what they're on, I guess, because I don't have the knobs on right this in a second. But here, let's turn them all the way down. They're all the way down now. Massive amounts of bass. I feel like this channel doesn't quite have as much bass as this, or I should say you can turn it down further than you can on this one. Treble all the way up. definitely, this channel is definitely a little bit more smooth, a little more mellow, meaning the treble and bass on this channel I feel like has these massive ranges, whereas this one's is just a little bit more, I don't know, it's a little smoother, it's not quite as extreme. So like all the way down, it gets a little darker than it does over here. And when you turn the treble all the way up, it's not as extremely tinty as this one all the way up. But I think in general, this channel sounds a tiny, tiny bit more scooped than this one does in the mids. I'm just switching some of my pickups to a different sound. Great sounding amp. I mean, just so crystal clear and 3D sort of sounding. I mean, this cabinet with these, I never really liked the sound of this. I like the sound of these speakers, but this little Ampeg cabinet in general, to me, just never sounded very good. But with this amp, it actually sounds incredible. This little 210. I mean, gosh, does that sound good. It's just so nice. Treble and bass all the way down on this one, and it sounds that good. So as you can see, I have to really crank. It gets super loud if I want to have it have breakup, but it's got such a powerful drive. I mean, more than a lot of Fenders that I've worked on recently in this sort of 60s and 70s era. It's just got so much power, and I think maybe some of it has to do with this Mercury. It's definitely outputting. It could be possibly outputting a little more oomph, like a little more efficiently than the original. But I still think with the original, it's just as good. I mean, unless you had an A/B switch where you could literally turn one off and turn one on, it'd be really hard to tell exactly. I mean, I feel like they're supposed to be clones of each other, but I don't know. There's just something about this amp in general that's just no wonder people like it. You know, it just sounds so good. It's got everything going for it. It's got the power. It's got the punch. It has the wide range of frequencies, even though it doesn't have a mid knob for you to control those. Now, that would be very easy to add. Maybe I'll talk to my friend about maybe adding a temporary one if he wants. You know, I know he wants to keep this original, but, you know, it would be very easy to do. There is an empty hole in the back there, so I'd have to run a couple of wires, but I believe there's like a 6.8 roughly K resistor off of one of the bass and treble pots here that you could just turn into like a 25K pot, and then you would be able to control the mid frequencies, at least on one of the channels. And it's a very easy thing to do if you want to have control of it. Otherwise, the mid frequencies are just kind of set for you with that one resistor. And that's just how it was on a lot of these old Fenders that didn't have a mid knob. But the mids can really change the dynamic of the entire amp and the frequency spectrum, allowing you to be able to control those and not be so scooped. Because if you look at a Fender, this Fender or any Fender around that time, if you look at it on a graph of what the average, you know, like if you put all knobs down, all EQ knobs, which are 2, and you look at a graph, it'll look like a equalizer graph. It'll look a little like this. It's very scooped. I mean, it's not super scooped like this, but it's, you know, it's got a pretty moderate scoop in the mid frequencies. So if you can raise those mid frequencies up a little bit with a variable pot from 6.7K or 6.8K up to 20 or so, then you can get that curve to look a little more up like this, and you can really get some power and punch in the mid range with an amp like this. But, you know, I think he probably wants to keep this as original as possible design wise, but that would be an easy one for us to just add a quick pot. You could literally just disconnect it with a wire or two and make it original again, or maybe even have a push-pull pot where you just engage it. Otherwise, it's not in circuit, or you pull it out and it is in circuit, so that you can use a mid-frequency pot on the back. So I don't know. I may talk to him about that, because I know he probably would like to control those mid-frequencies. And we could even try it by tacking in a pot with a couple of, you know, little test leads, just to see what it would sound like. And I've done that a lot on Fender Princetons and stuff that I've built clones of that didn't have the mid knob on it, and it really does make a big difference. I mean, if you're a tone junkie, it is being able to control that and not just have it set at one value all the time can make a huge difference in your amp. So anyway, hope you like the sound of this. I'm loving it. I think it sounds killer. I can't wait to get his new speakers. But in the meantime, I got a little more testing to do. I'm going to rip these speakers out. I'm going to clean this cabinet off. We're going to get everything restored as possible.
Когда луна в ночи восходит, ее сияние звезды гуди, серебряных подобно лед, в синях узоры тьмы плещет. Если себе сияние небосвода, все руки проводят, смело снова отворят, и своих рам тайна. Ее прекрасен, прозрачен воздух, чистый ясен. Иди попей, играешь фон, ты украшаешь небосвод. Если себе съемка небосвода, все руки проводят, still снова пойдет, своих не пойдет. Бывают дни, когда желания переполняют мироздание. Ты ловишь солнце, сварил сеть, тебя холодную согреть. With the beat, the groove, dance with ease. Mephistopheles, move with the beat. The groove, dance with ease. The step. On the floor, to the crowd, shout of peace. Mephistopheles, move with the beat. The groove, dance the breeze. Mephistopheles. little groove, dance with ease. Mephistopheles, move with the beat. Little groove, dance with ease. Spoon on the floor, to the crowd, shout out please. Mephistopheles. With a beat, little groove, dance with ease. Mephistopheles.
Alright, welcome back friends to another section of this video. Almost wrapping up here. Actually, the amp is pretty much all done and all restored. I don't know if you watched or skipped through any of the time-lapse videos on the cleaning of this, but it was extremely detailed work. I even got out the buffing wheel for the hardwares and did a vinegar bath for the rust on everything metal that had rust. That worked fairly well, but I still needed to do some WD-40 scrubbing with a wire brush and some hit it with some steel wool, and then do the polishing. But it worked really well. It's just some of the metal is a little pitted, and you would expect that for a 60-some-year-old amp. I did have to put new feet on the bottom, but I did wind up going with... I was going to put original Fender style feet, but I talked to the customer, and those are just not great because they're metal, and if you have a hardwood floor, then you can scratch up your hardwood floor. The feet, when I took them off, the rubber inside those little metal casters just completely crumbled, and they were very jagged and sort of flattened out, and they would have definitely cut up a floor. So decided to go with these rubber ones for now, and they're nice heavy duty sort of Reese's peanut butter cup shape. But that for the weight of this amp, this is just a better way to go and not have to worry about scratching up any floors that you put it on. And also for rattle reasons, because those metal ones can rattle if they're not sitting on an even floor when you play, because this amp will definitely rumble the house or wherever you're playing it. So right now, these are not the speakers that are going to stay in there, but they're the same type and brand. These are mine. I put them in there as a test, and I'll do a final demo with these. These are Raging Cajun Eminence speakers, 16 ohm each, wired for 8 ohms. Now this amp is looking for 4 ohms, so this is a safe mismatch, and for demo purposes, I think it's going to work just fine. But my customer is going to be bringing me 2 8-ohm speakers, and we're going to wire it for 4 ohms to do proper impedance matching. And that's his preferred style of speaker for a lot of these old Fenders, and I agree with him. I think this amp, I've owned these speakers for a long time, and I've had them in a little 210 cabinet, and any amp I throw at them, I wasn't that impressed. But this amp, and like a Fender Princeton type of an amp, or definitely those, blackface era, and even some of the silverface era amps, these speakers are awesome. I just think they sound so great, so full, so round, very 3D sort of sounding, and I think they're going to be fantastic for this amp. Again, this amp did not come with the original speakers. It had something else in there. There was a problem with those speakers rattling, and they just didn't sound good at all. So we took those out. We decided to go with these. So when he comes by to pick this up, he's going to bring his 2 speakers so that we could just swap these out and have the proper impedance. So what I've done here is I've created a nice new wiring harness. Didn't want to use the old one because it was damaged, and the plug was kind of wonky too, so I basically just made a new little wiring harness here with a new pancake jack. You don't have a lot of room here once you have the back panel right here, and you would not be able to unplug this if you had this type of an angled jack or anything larger than that. It's just not enough room. But with this, you can sort of get it in and out of there if you needed to unplug it with the back on it. So, and I just put this little wire guide here so that I can just kind of tuck it up under those wires so it's not leaning against this. I didn't do a very good job of that. So it's not leaning up against this tube and getting too hot or melting anything. But yeah, I mean, all these have been polished. Every jack and everything, switch has all been cleaned. Did a little bit of sort of wire management here with the reverb tank, so that's very nice and secure, away from tubes, shouldn't pick up any noise. The inside of this thing looks just absolutely awesome, clean. There's the reverb tank, everything's been cleaned there, and protectant put on the Tolex for that. And as I do in every single amp that I own and every single amp that I repair and restore, as long as I remember to do it, I always put spare fuses. It's a good practice to get into. I highly recommend it. This amp calls for 2 amp slow blow fuses, and I made sure that's what we got in here. But also, you never know. What if you're playing, you're recording, you're in the middle of a song,
something happens, a fuse blows. If it blows and you're plugged into like a power strip or something, try not plugging into that power strip. Maybe take it into a different room. Try it in a different outlet with a new fuse in it. Make sure you unplug it first before you take the fuse out. But then pop a fuse in, and if it's good to go and you play it for a while, nothing happens, you're probably fine. It may have been just a malfunction with that, either that power strip or that outlet. But if you blow another one, do not turn your amp on anymore. If it blows a couple of fuses, something's wrong in that amp. There's a short, a tube is going bad, causing a short, drawing excess current. If it goes over the, ooh, hear that? We're getting a major storm outside. So it's kind of dark and eerie in my room right now. But yeah, just general rule of thumb, just use your head. You know, the fuse is there to protect the internals of your amp. I say this on every video, but it's so important, and I see way too many times where people put the wrong rated fuse in their amp because it's blowing fuses, and they put like a 20 amp car amp fuse in it, which happened in one of the recent repairs I just did with an old 70s silver face Fender. And yeah, if it's doing that and you force it to stay on, you're going to burn up more than, you know, you're just a tube or two. You're going to burn up the transformers and everything else and cause, maybe even start a fire. So it's very important to always just use the rated fuse. If it's continuing to blow fuses after two, don't keep trying it. Turn it off, unplug it, take it to your tech. So yeah, got the extra fuses in there just in case. Safety call. And yeah, this thing is, I mean, I am just super happy with this, and I think it sounds so good. It not only looks great, but it sounds great. And we're gonna get this back panel on here. The one thing that I did with this restore that I didn't even notice, there's certain lighting. Hold on, so I'll try to line this up. There's certain lighting that I've kind of been working on this amp in, and like whether it's sunny and there's a window back here or not, or just this overhead lamp or other lamps I have in the room. When I washed this thing, I didn't see, it looked like I had gotten all the paint off of it. I know I got all the big stuff because there was these big red blotches of paint on the sides and stuff like that. I got all that up, but there's still, that's dust. There's still little tiny white specks. And I see this a lot on so many old amps and especially old antique radios where it has, you know, like a wood shell. You can see little dots of white. It's always white paint. It's always little tiny little specks. And I think I figured out what that's from. It's people back in the 40s and 50s, 60s, whatever. I don't know why, but it seems like no one used drop cloths back then when they were painting their house. So they had all their stuff sitting around, and you know, they were just painting the house. And I'm sure painting the ceiling, you're going to get all these little splatters, because I've seen it on, you can see it on drop cloths that you put down when you paint, and you'll see these little tiny specks. That's from little splatters from painting your ceilings. And it's always white paint, which most people usually paint their ceilings with some kind of white or a cream based paint. But it's like every amp, every radio, there's always little white specks on it, especially if they're like 1960s or older. So it's just one of those things that I'm just like, come on guys, you could have just put a little, at least cover your amp, you know. But anyway, it's part of the nostalgia and the history. I mean, it is what it is. I could spend lots of intricate time getting every little tiny little dot of paint off with like a little scraper very carefully and then repolish everything. But, you know, at this point, it is what it is. Most instances, you're not going to see it unless you're right up on it. And I think cleaning it the way I did with the scrub brush did get most of it off. There's just still a couple of little areas that I'll notice some white specks, and I'm like, darn it, I thought I got that clean. It looked like it was clean. But in this lighting, I still see one. Like, here's one little speck right there. You might not be able to see it on this camera, but it's there. And I'm like, son of a gun. Oh, another thing I did here, very simple thing you can do if you have one of these Fenders where you need a foot switch to be able to turn the vibrato on. Most of these Fenders around this era that had vibrato and reverb, they usually have it where the reverb will work just by turning the reverb knob up without a foot switch needing to be plugged in, but the vibrato will not. If it has one of those little roach clip type of lighting systems to make the vibrato work, it's a little, thing that has a light inside of it. By default, you can't use the vibrato without at least plugging in the foot switch. So what you can do is you can short that out. If you connect the inner part of the RCA jack with the outer part, which is the ground, then it grounds it out and the vibrato will stay on all the time. You can turn it off by just turning the intensity all the way down to 0. But if you want to use it, the amp, with the vibrato effect without having to get out your foot pedal, you can make one of these little dongles, and you can make them out of all kinds of things. But I just took a little RCA jack. Let's see if I can show you what this looks like. Right, so it's just a little RCA. You could take an old piece of RCA cable and cut this little piece off, and I basically just put a little wire in through, and it comes out the tip here, and just solder it on the tip, and then bend the wire over and solder it to the outside of the, basically you're just trying to connect the inside with the outside. Sorry if this is out of focus. There you go. So that little glob of solder there, I just took a little piece of metal, put it through the end, soldered the end, and soldered it against the casing here. If you pop that in where the vibrato pedal is, it'll short out vibrato, and you can use it at any time without needing a foot switch. Now this amp does have the foot switch, but you might not always need it. And the more you use a foot switch with an amp like this, the more you're going to potentially introduce noise, because very importantly, I'm going to show you these foot switch pedals. I've gone and cleaned all this out too and everything, but this wire here is not the best insulated wire. I mean, it's okay, but it's not the greatest. And when you put a really long wire like this, I heat shrunk the ends of these just to keep everything a little more secure, but when you use this becomes like a big antenna. So you could be picking up a lot more noise if you have this plugged in and introducing it into your sound. So if you're not using a foot switch, you're going to potentially have a much quieter amp if you keep this foot switch unplugged. Just keep that in mind with these amps. I mean, these are, they are shielded. Like the Reverb Tank one is shielded because it does have signal going through there. But now you're extending your guitar signal way outside of the amp and bringing it back into the amp through the tank and then back out again. So if you have a foot switch here, it's just better to not use it if you don't have to. Now, if you're doing a live performance, that's fine. But if you're recording or you're playing at home, you can use this so you still have use of all your effects and it stays much quieter. So yeah, keep that in mind. And let's get on to the final thing, which is final demo, and you'll be able to hear what it sounds like with actual speakers, even though they're not the right ohms. The amp might not be quite as loud or quite as punchy as they will be once we put the 2 8-ohms in and wire it for 4 ohms. That's what this amp is looking for, is 4 ohms. But it'll still sound 99% the same as what he's going to have once this, we get his speakers in there. So let's get to it. Man, this amp is sounding so good. It is absolutely dead quiet. There it is on 10. Barely hear a tiny bit of amp hiss, you know, normal, but super quiet. I feel like there's a really nice difference on the bright switch. I've built a lot of Fender Bassmans, blackface, silverface, stuff like that, and I feel like the bright switch isn't quite as extreme or as noticeable sometimes, but this is like, it's got a perfect EQ range. So with the treble all the way down, bass on 5, bright switch. Let's put the treble on 5 with the bright switch down. Then up. The bass has a nice bass sounds good, at least with this guitar. Let me try a different pickup. Sounds good between 3 and 4 to me. And I've got the treble on 7, but that's with the bright switch down. If I turn the bright switch up, I gotta turn that back a bit. If you really want those clear notes, you should have the bright switch up and then just cut it back to, it's on 4. So actually between 3 and 4 on the bass and 3 and 4 on the treble, that sounds pretty balanced. Maybe a little more treble. Reverb's got a really nice drippy sound. So that's all the way up. Doesn't need to be that loud. I feel like 3 and 4 is like the sweet spot on that too. Sorry, didn't realize I was going that far out of tune. Okay, here's the normal channel. Controls are all the way down. Now they're on 5. Bright switch up. am just not warmed up or in the playing mood tonight, so sorry about my playing, but just trying to let you hear some of the tones now that this thing is fully restored. And with these speakers in it, the Eminence speakers, they sound really, really good. Such a loud amp. I mean, gosh, these two 6L6s definitely kick out some volume. got such good sustain. Even with the reverb off. Just listen to how long that goes. Just goes forever. Man, I'm not worthy of this amp. My playing definitely can't showcase what this amp can do. I'm too much of a rocker trying to play really pretty stuff, but or just weird. I don't know what you want to call that, but I'm just trying to showcase, and it's just such a cool amp. I've never heard this particular amp before. Worked on one of these. This is the first time, and you know, a lot of people definitely prize it as one of the best. Probably a Fender Deluxe, like a, is it a 60? What's the one? Is it a 64 Fender Deluxe? Is one of the best Fender amps of all time. I forget what the year is, but I feel like this is very close to that because I have worked on a Deluxe of that era before, and I don't know. There's something about this. I feel like there's more sustain. There's a little bit more. I don't know. Something to it. You know, Fender did a lot with these circuits where they made them very similar to each other, but changed a few things or added a couple of features here where they didn't have them on that one, and so on. But I don't know, if you've worked on them and played them long enough, you can definitely tell each has its own sort of signature thing going on. And I feel like depending on the guitars you're using, you know, you're going to get different feels and different sounds out of it. But this one, I can say one thing that stands out to me is the sustain is off the hook. I mean, the notes go forever. And it's not like woofy sounding, although it has a ton of bass. It just sounds very punchy, very good. But also there's a little bit of that vintage sag feel. Probably because the filter caps are such a low value of, what were they, 16 UF, I think. Which is lower than most Fenders of the era. Most of them had 20 UF caps or higher. Maybe two in series for 40 UF for the first main filter cap, but this is all 16, so there's definitely a vintage feel. It's got the rectifier tube is definitely giving it a vintage feel, but that GZ34 is very powerful, so you still get a lot of punch out of this. But I just feel like this is definitely, it's like a powerhouse, but it still has the vintage feel without it getting too modern feeling, you know? I don't know, that's just my take. That's what I'm feeling here now that everything's done. It's all restored, it's all serviced, it's working great. There's absolutely zero noise coming from this thing. It just sounds awesome. I just wish I had I don't know, something better to play for you guys. I just wasn't really prepared here. I could plug in my Jaguar, but it's a Squier Jaguar, so it's not a very good one. I don't think it sounds that fantastic or anything like that, but
Let me throw that on for a second.
Yeah, sorry guys, I tried my Jaguar out, and one, it needs new strings, but two, it is so far out of intonation right now, it sounds awful. You could tune it up to one chord and then you play another chord and it's completely out of tune. So I'll just use the Strat for now, just to get something a little different. The pickups are definitely a lot louder here, unless I get further away from the amp. Alright, enough of that. This amp just sounds so great all over. I'm just not in the playing mood right now, and I just don't know what to do. But hopefully you get an idea. The main part of this video is really just restoring it and showing you what I did to restore it, in case it gives you any ideas if you have one of these or a similar model. If you have any questions, please let me know. You can reach out to me on just about all the social media platforms. You know, I'm happy to answer any questions about this stuff. I love to share the info and my experiences and help anybody out that is having trouble with something. But hopefully this video gave you some pretty good ideas about what an amp of this age would need service-wise. This one was in just such great shape to begin with. Really just needed a really good cleaning and a nice servicing and some caps, and all the tubes we kept. I mean, all of them were good. We didn't have to replace any, so that was amazing to be able to do that for an amp of this age. 60 some years, and we're using probably mostly original tubes. I know one of them might have been replaced, the power tube, because of the mismatch in brand there. I don't think Fender would have sold an RCA and a Sylvania. So maybe one tube was replaced at one point, but just a glorious sounding amp. I was so happy to be able to work on this holy grail of an amp here. But if you ever get a chance to pick one of these up, you should, because it is definitely one of the better ones that I've played. And I've played and cloned many Fender amps. So this is definitely a good one. All right, adios. I'll see you on the next video. Thanks for watching.